P naught A chi A plus P naught B chi B minus P naught B. எப்படி மேம் வந்தீங்க? ஒன்றும் இல்லைடா, இது வந்து ஃபர்ஸ்ட் எழுதுறதுக்கு பதிலாக இது லாஸ்ட் எழுதிட்டேன், அவ்வளோதான். எனக்கு வந்து இந்த கையே கைபின்னு இருக்குல்ல, I want to do any calculation also there, right? The value of the vapor pressure, or I mean relative lowering of the vapor pressure or depression in freezing point, everything will be same. You just want to do the calculation only. You don't want to give the value of I. So usually they will be giving you that only, but in some cases they can give this also. So non-volatile solute நம்ம add பண்ணிட்டோம். Non-volatile solute நம்ம add பண்ணும்போது listen carefully, this is very important. Hello students, எப்படி இருக்கீங்க எல்லாரும்? How are you guys? All good? So this is our second one shot, right? ரெண்டாவது ஃபர்ஸ்ட் நம்ம சொல்யூஷன் எடுத்துட்டோம். இன்னைக்கு நான் சொல்லியிருந்தேன்ல, இன்னைக்கு அந்த கிளாஸ்லேயே வந்து ஃபர்ஸ்ட் ஒரு சாப்டர் வந்து 11th இருக்கும், நெக்ஸ்ட் வந்து 12th ஒரு சாப்டர் இருக்காங்க. ஸோ இன்னைக்கு நம்ம வந்து சம் பேசிக் கான்செப்ட் தான் 11th எடுத்தோம். ஸோ இப்போ இன்னைக்கு வந்துட்டு 12th சொல்யூஷன் எடுக்கலாம். ஏன்னா கொஞ்சம் தே ஆர் ஆக்சுவலி ரிலேட்டட்னா, ஸோ வி கேன் கோ ஃபார் தட். ஓகே, ஸோ சொல்யூஷன் வந்து சொல்யூஷனில் ஃபர்ஸ்ட் போர்ஷன் எப்படின்னா, இந்த mass by mass percentage, mass by volume percentage, volume by volume percentage, mole fraction, molality and what is a solution, இதெல்லாம் தான் நம்ம படிக்கிறோம். ஹென்ரி லோ, ரோல்ஸ் ரோ, அதோட ஐடியல் சொல்யூஷன், நான் ஐடியல் சொல்யூஷன், அது எப்படி என்னென்ன டிவியேஷன் வருது, அசோட்ராப்ஸ் வைக்கலாம், எல்லாமே தான் நம்ம பார்க்க போகிறோம். வேப்பர் ப்ரெஷர், பார்ஷியல் ப்ரெஷர், எவ்ரி திங். செகண்ட் போர்ஷனில் வரும்போது தான் கொலிகேட்டிவ் ப்ராப்பர்ட்டிஸ் சொல்கிறது. என்னது கொலிகேட்டிவ் ப்ராப்பர்ட்டிஸ், இதெல்லாம் ஃபேக்டர்ஸ் கொலிகேட்டிவ் ப்ராப்பர்ட்டிஸில் இருக்குது. ஸோ லாஸ்ட் இது எல்லாமே முடிச்சதுக்கப்புறம் இந்த கொலிகேட்டிவ் ப்ராப்பர்ட்டி எப்படி கண்டுபிடிக்கிறது, இல்லைனா அதோட அந்த how it is like எப்படி அது வந்து கனெக்டட் ஆயிருக்கு, அதோட எல்லாமே ஒரு சின்ன சீட் நோட்டும் நான் கொடுக்குறேன். ஓகே, so this is what we are going to discuss in this today's session. Shall we start our session, children? Everyone is ready with your pen and notebook? Okay தானே? Okay, so first of all we are going to discuss, one second children, அதுக்கு முன்னாடி இதை எடுத்து இங்கே வைக்க முடியுமான்னு பார்க்கட்டும். ஓகே, கரெக்ட். Okay, now we are going to know about what is a solvent. So solvent basically இதில் இருக்கிற தேவையானது மட்டும்தான் நான் இதில் இருந்து உங்களுக்கு எது தேவையோ, what is needed for you, I'm just discussing that. Okay, so solvent means always solvent is the largest component. ஒரு solventல solution என்ன சொல்லும்போது, ஒரு solutionல solute இருக்கும், solvent இருக்கும், ஆமாம் தானே? solvent சொல்கிறது தான் யூஸ்வலி அதோட larger componentஆக இருக்கும், அந்த சொல்யூஷனை பேஸ் பண்ணி. solute சொல்கிறது அதோட என்னதாக இருக்கும், relatively smaller content-ஆக இருக்கும். Just a second children. One second. Solute சொல்றது ரிலேட்டிவ்லி ஸ்மாலர் கண்டென்ட்டாக இருக்கும். ஸோ ஒரு சொல்யூட்டும் சால்வெண்ட்டும் ஆட் பண்ணி தான் என்னது நடக்குது, சொல்யூஷன் நடக்கிறது. ஹோமோஜீனியஸ் மிக்சர் இஸ் a single phase containing more than one component dispersed on a molecular scale. ஒன்றும் இல்லை, ஹோமோஜீனியஸ் சொல்கிறது கம்ப்ளீட்லி டிசால்வ் ஆகுது. நம்ம சம் பேசிக் கான்செப்டில் படித்தோம். கம்ப்ளீட்லி டிசால்வ் ஆகணும் ஒரு ஃபேஸை தான் சொல்யூட்டும் சால்வெண்ட்டும் கம்ப்ளீட்லி டிசால்வ் ஆகணும் ஒரு ஃபேஸை தான் என்ன சொல்கிறது, சொல்யூஷன் சொல்கிறது. நவ் ஒன் செகண்ட், நவ் ஒரு விஷயம் இங்கே சொல்கிறதுக்கு என்னென்னா, இப்போ வாட்டர் சொல்கிறது, வாட்டர் கேன் பி இந்த லெஸர் குவான்டிட்டி அண்ட் மோர் குவான்டிட்டி. ஃபார் எக்ஸாம்பிள், நம்ம இப்போ வந்து சால்ட் சொல்யூஷனே வந்து ஹை கான்சன்ட்ரேட்டட் சால்ட் சொல்யூஷன் எடுக்கும்போது அதில் சால்ட்டோட அமௌண்ட் அதிகமாகிட்டு வாட்டர் வந்து நமக்கு கம்மியாக இருக்கும். ஸோ பட் இன் தட் கேஸ் ஆல்சோ வி வில் பி கன்சிடரிங் திஸ் பர்டிகுலர் வாட்டர் ஆஸ் எ சால்வெண்ட் ஈவன் வென் இட் இஸ் ப்ரெசன்ட் இன் தி வெரி லெஸ் அமௌண்ட். ஈவன் தோ அது வந்து சின்ன அமௌண்ட்ல இருந்தாலும் நம்ம அந்த எதாவது கன்சிடர் பண்ணுறோம், வி ஆர் கன்சிடரிங் இட் அஸ் அ சால்வெண்ட் only. And solvent determines the physical state which the solution exists. Solvent தான் அந்த ஒரு சொல்யூஷனோட physical state, whether it is a solid or whether this is a solute, I mean not solute, liquid or gases, it is denoted by or it is determined by the solvent. Now based on their number of solute எவ்வளோ இருக்கோ அதோட அமௌண்ட்ல we have the binary solution, ternary solution and the quaternary solution. So if there is one solute and one solvent means it's binary, two solute and one solvent means ternary, and three solute and one solution, I mean solvent means quaternary. Once both are equal means binary, 2 1 means ternary, 3 1 means quaternary. Clear everyone? These are just basic only, like it's not that much important one, but I'm starting from the basic. Okay, liquid solution la, so there are liquid solution when we are telling gases are in liquids, like சொல்யூஷன் வரும்போது solute solvent வரும்போது லிக்விடும் கேஸும் வந்து மிக்சர் ஆகிட்டு சொல்யூஷன் ஆகுது. அதே மாதிரி லிக்விடாக இருக்கிறது alcohol and water. இப்போ கேஸஸுக்கு carbonated drinks are example for this and alcohol and water is an example. Solid in liquid, that is salt and water. So these are the liquid solutions. Liquid solution means liquidum இருக்கும், அது கூட either solid or liquid or gas. So solid, gas in liquid, liquid in liquid and solid in liquid. Next one is percentage concentration terms. This is very important, which we have already discussed in the some basic concept la. Idhula irundhu I want to tell in a very big point here. Idhula irundhu direct questions edum kekka maatanga. They won't be asking the direct questions from this because even for the boards also ungaloda and the state board exams ko illa NCERT board exams kella CBSE board exam kella idhula irundhu direct questions aakamathu. This is very basic, but they will ask you the questions in such a way that idhula irukra information use panni vera edavadhu kepanga. Okay, so we will do the questions also. I'm not going for the questions and all, I'm just taking the chapter only without going for not much in the practical questions. Okay, so here first one is the volume by volume percentage. Volume by volume percentage. Volume by volume percentage is the amount of the solute which is in the grams divided by a weight of the solution. Listen, everyone listen here. This all the percentage terms are கீழே வந்து என்னதான் இருக்கும், சொல்யூஷனாக தான் இருக்கும். மொலாலிட்டி டிஃப்ரெண்டாக இருக்கும். இங்கே எல்லாமே கீழே வந்து என்னதான் இருக்கும், சொல்யூஷனாக இருக்கும். ஸோ வெயிட் ஆஃப் த solute divided by weight of the solution. Since it is weight, it is in the grams. Okay, weight of the solute in grams divided by volume of the solution, which will be in the ml. Which will be in the ml into 100. This should be like this, into 100. Here also அது கொஞ்சம் rewrite வந்திருக்கேன், into 100. That is the volume by volume percentage. See, mass by mass percentage is equal to amount of the solute. This is denoting mass, children, hereafter. This is very important. This is denoting the mass. I will write with some other color because one second, உங்களுக்கு இந்த கலர் கரெக்டாக இருக்க மாட்டேங்குது. இந்த கலரும் கேவலமாக இருக்கே. I guess white will work here. Okay, this is actually the mass, and I want to tell you here, you may confuse this with, okay, this is a weight or something. No, this is the mass. Okay, this is very important. This is the mass. Another m will be that is there in here, that is actually considered as the molar mass. Okay, that is actually the molar mass. In order to அவங்க ரெண்டுமே நம்ம வந்து there are many equations which ரெண்டுமே இருக்கிற equations இருக்கும், அதில் நமக்கு ஐடென்டிஃபை பண்ணுறதுக்கு தான் here after mass will be W and molar mass will be the M. This is not molarity or molality, like molar mass. Okay, M. I will do one thing. Molar mass. Okay, capital letter M தான் இருக்கும் molar mass. And I want to tell you one more thing. 1 means it is solvent. Okay, 2 means it is solute. What is this 1 and 2 means? If I'm telling you M2 means it is the molar mass of the solute. W2 means it is the mass of the solute taken. Are you getting my point? Are you getting my point? See, M1 means molar mass of the solvent. One second, children. M1 will be the molar mass of the solvent. W1 will be the mass of the solvent. So 1 will be denoting the solvent and 2 will be denoting the solute. Chi 1 means it is with respect to the solvent. Chi 2 means it's respect to the solute. This also I want to add here because in upcoming இந்த கிளாஸ்லேயே வந்து நிறைய இடத்துல நம்ம அதை டிஸ்கஸ் பண்ணுவோம். ஓகே, ஸோ amount of the solute in grams dissolve in 100 ml of the solution, that is mass by volume, which is actually in the ml. Okay, volume by volume means it's the volume of the solute which is in the 100 ml of the solution. Clear, everyone? Clear? Now we are going to discuss about the other concentration terms, and this is very important, especially this one, everything is important, children. Okay, so they are molarity, normality or mole fraction, strength, molality, parts per million. These are very important other terms which we are going to discuss: molarity, normality, mole fraction, strength, molality and parts per million. Now molality, strength, first of all we are going to look into the strength of the solution. First one, we are going to look into the strength of the solution. Weight of the, this is my handwriting, children, I know that it's little weird, I will write it one more time, don't worry. Okay, weight of the solute in grams per liter, that is per liter means how much, for example, if you are taking 1 liter of solution, how much is the weight of that particular solute in that 1 liter of the solution, that is the strength of the solution. I repeat, if you are taking 1 liter of the solution and how much is the weight of that particular solute which is in the 1 liter of the solution, that is the strength of the solution. So we can say that weight of the solute divided by volume in liters. 1 liter is equal to 100 ml. So volume in liters, strength is equal to, and their unit is gram per liter. Now I want you to note here one more point. Gram per liter da கொடுத்திருக்காங்க, kg per liter இல்ல. So weight of the solute சொல்றது எதில தான் எடுத்திருக்காங்க, they have taken in the gram. This is very very important. Weight of the solute எதில எடுத்திருக்காங்க, they have taken in the gram. In how many liters of the solution, 1 liter of the solution எடுத்துட்டேனா அதுல எவ்வளவு amount of solute நான் ஆட் பண்ணியிருக்கேன், அதுதான் அந்த சொல்யூஷனோட weight சொல்றது. பக்கா? Okay. Now comes the molarity and molality. In the molarity is very important. நம்ம colligative properties எல்லாமே படிக்கும்போது படிக்கிறது தான். So molarity சொல்றது, listen carefully, ரிட்டில யோசிச்சுக்கோங்க, ரிட்டில லிட்டர் இல்ல. I'm sorry, no. அப்படி இல்ல, திருப்பி சொல்லிட்டேன். லிட்டில லிட்டர் இல்ல. மொலாலிட்டி வரும்போது அது லிட்டரோட பேசிஸ் இல்ல, லிட்டில லிட்டர் இல்ல. ஸோ மொலாலிட்டியில் என்னதான் இருக்கும், வெயிட் ஆஃப் தான் இருக்கும், சால்வெண்ட் தான் இருக்கும், கிராம்ஸில் தான் இருக்கும், இல்லை கேஜியில் தான் இருக்கும், லிட்டரில் இருக்காது. மொலாலிட்டியில் லிட்டர் இல்லை. அப்போ எதில் லிட்டர் இருக்கும், ரிட்டியில் லிட்டர் இருக்கும். ஐ ரிப்பீட், லிட்டியில் லிட்டர் இல்லை. என்ன மேம் சொல்கிறீங்க, லிட்டியில் லிட்டரா ரிட்டரில் லிட்டரா? ஆமாம் தானே, இப்படி யோசிச்சுக்கோங்க. லிட்டியில் லிட்டர் இல்லை. அப்போ எதில் லிட்டர் இருக்கும், ரிட்டியில் இருக்கும். இதுதான் மொலாலிட்டி ரொம்ப கன்ஃபியூஸ் பண்ணுவாங்க சொல்ல. ஆல்வேஸ் ரிமெம்பர், ஓகே லிட்டியா லிட்டர் இருக்காது, அப்போ அதில் என்னதான் இருக்கும், வெயிட்டில் தான் இருக்கும். ஸோ ரிட்டி சொல்கிறது நம்பர் ஆஃப் மோல்ஸ் ஆஃப் சொல்யூட், ரெண்டுமே நம்பர் ஆஃப் மோல்ஸ் தான். தெர் இஸ் நோ டிஃப்ரென்ஸ் இன் த நியூமரேட்டர். Number of moles of solute in the 1 kg of the solution, number of moles of solute n in which is the mass of the solvent, not solution children, solvent, mass of the solvent which is in the kg. Are you getting my point children? Are you getting my point everyone? லிட்டியில் லிட்டர் இல்லை, அப்போ அங்கே எந்த தான் இருக்கும், என்ன இருக்கும், மாஸ் தான் இருக்கும். ஸோ மாஸ் ஆஃப் த சால்வெண்ட் which is in the kg. If they given in the grams means you have to, I mean கிராம்ஸில் தான் கண்டுபிடிக்கணும்னா into 1000, right? Now number of moles of solute per liter of the solution. So number of moles of solute which is n, volume லிட்டரில் இருக்கும், லிட்டரில் எதில் இருக்குது, ரிட்டியில் இருக்குது, லிட்டர் எதில் இல்லை, லிட்டியில் இல்லை, லிட்டியில் லிட்டர் இல்லை. இப்படி யோசிச்சுக்கோங்க. And of course the formula, I mean the simple is capital letter M here and the small letter m here. We discussed this already in the some basic concepts. But yeah, again I'm just telling you. Now this is also another important one children. Normality இங்க வந்து கொஞ்சம் கன்ஃபியூஸ் பண்றதுக்கு சான்சஸ் இருக்கு, நல்லா கவனமா இருந்துக்கோங்க. So normality சொல்றது number of, I'll tell you what all the things actually இதுல என்னெல்லாம் இருக்கு எதெல்லாம் எல்லாமே சொல்றேன், கொஞ்சம் பார்த்து இருந்துக்கோங்க. Number of gram equivalent of the solute divided by the volume of the solution. So molarityயும் நார்மாலிட்டிலையும் டினாமினேட்டர் ஒன்று தான். ஐ ரிப்பீட், மொலாரிட்டியும் நார்மாலிட்டியும் டினோமினேட்டர் ஒன்று தான். கனெக்ட் பண்ணி படிச்சிட்டா தான் ஞாபகம் வரும் ஈக்குவேஷன்ஸ். இப்போ நீங்கள் சொல்வீங்க மேம் என்னது நம்பர் ஆஃப் கிராம் ஆஃப் ஈக்குவலன்ஸ் எப்படி கண்டுபிடிக்கிறது? மாஸ் ஆஃப் தட் பர்டிகுலர் ஸ்பீஷஸ், வாட் எவர் இஸ் ஸ்பீஷஸை விட சப்ஸ்டன்ஸ் தான் சொல்கிறது இன்னும் பெட்டர். என்ன சப்ஸ்டன்ஸ் உங்களுக்கு கொடுத்துருக்காங்களோ அந்த சப்ஸ்டன்ஸோட மாஸ் டிவைடட் பை கிராம் ஈக்குவலன்ட் மாஸ், டிவைடட் பை gram equivalent mass. Now you may ask, mass I got it ma'am, that will be giving in the question. What about the gram equivalent mass? I'll tell you my dear students. See a gram equivalent mass சொல்றது கொடுத்திருக்கிற சப்ஸ்டன்ஸோட molar mass divided by n factor. See that's why the equation gives like, one second I will write it as a one minute. ஐயோ என்னடா ஆச்சு? So what we were discussing? We were discussing about the normality. Na? Normality is equal to, what was the equation children? One second, what happened to this? Number of number of gram equivalent mass divided by volume of the solution in liter. Now gram equivalent mass is equal to gram equivalent mass. Okay, I'm just giving the short form. Gram equivalent mass சொல்றது என்னதா இருக்கும் சொல்லுங்க எவ்வளவு மாஸ் எடுத்திருக்காங்க that particular mass of the species or substance in grams divided by what was it? Divided by their gram equivalent mass. Gram equivalent mass. In the gram equivalent mass தான் நமக்கு we have to find it out this particular gram equivalent mass, right? This particular gram equivalent mass, gram equivalent mass. Adu okay, equivalent G. Okay, gram equivalent mass, which is equal to molar mass divided by n factor. N factor என்னது ma'am கேட்டேனா it depends upon the substance. I'll tell you what is this. One second. Did I miss anything? Equivalent mass. Okay. இதுதான் அதுல கொடுத்திருக்காங்க. So இதுல வந்து முதல்ல நம்ம क्वेश्चनல கண்டுபிடிச்சேனா நம்ம மோலார் மாஸ் அந்த சப்ஸ்டன்ஸோட கண்டுபிடிக்கணும். அதுக்கு அப்புறம் இதுல இருக்கிற n ஃபேக்டர் பார்க்கணும். n ஃபேக்டர் என்னன்னு நான் சொல்றேன். For example, okay, I'll tell you. Okay, இது கண்டுபிடிச்சதுக்கு அப்புறம் அந்த வேல்யூ வந்து நம்ம இங்க போடணும். Okay, denominator. Then we have to get the number of gram equivalent mass. We have to calculate or we have to put that value in the denominator of the, in the numerator of this particular normality. Are you getting my point, children? Now, you may ask that, ma'am, what is this n factor? N factor சொல்றது it depends upon the substance. For example, you will be having the salts like KCl, NaCl and all. அதுக்கு n factor different இருக்கும். Acid basesக்கு n factor different இருக்கும். Oxidizing reducing agentsக்கு different இருக்கும். Oxidizing reducing agent அந்த அளவுக்கு क्वेश्चनல வர மாட்டா, but still I'm telling you, oxidizing reducing agentக்கு அவங்களோட electrons தான் அவங்களோட n factor. How many electrons? See, number of electrons evolve in the oxidation and reduction half reaction per molecule. You will learn about the half reactions and all. Those who are in the 12th standard, you have already learned about it, right? 12th standardல இருக்கிற redox reactionல 11thல இருக்கிற redox reactionல நம்ம படிச்சிருக்கோம். ஆமா தானே? அந்த பேலன்சிங் பண்றதை எப்படி நம்ம படிச்சிருக்கோம். அதுல வந்து when we are adding the number of electrons now for the oxidation and the reduction, that particular number of electrons which we are added is actually the n factor. So 5 will be the n factor of this particular one, like for this example. So whatever is the amount electrons we are adding or involving or it is taking part in that particular reaction, that is the n factor when coming to the oxidizing and reducing agents. Are you getting my point, children? Are you getting my point? Okay. Next one, ma'am, while for the bases and the salt. Here I have to say exception also. I'm telling that now. So listen carefully. So acid, bases and salt la acids la வந்து how many hydrogens are present? For example, HCl. HCl ஒரு hydrogen தான் இருக்கு. So n factor will be 1. H2SO4 ல ரெண்டு hydrogens இருக்கு. So n factor will be 2. Correct? And this NaOH. Now, so number of moles of H plus displaced by or OH minus displaced per molecule is the acid basis. For example, if you are taking NaOH, okay, NaOH எடுக்கும்போது என்னதா இருக்கும்? அதுல எவ்வளவு OH இருக்கு? ஒரு OH தான் இருக்கு. So that will be N is equal to 1. Are you getting my point, children? Are you getting my point? Now for simple salt for the n factor is the charge on the cations or total charge on the anions. For example, you have Al2SO4 thrice. What will be the charge? It can be, what will be the charge? Tell me. Charge on the cations will be, what is the cations and what is the anions here? This will be dissociated at 2Al plus 2, this will be dissociated and there will be the 2, see, 1 Al will be having 3 electrons. 3 charges, 3 plus, right? Here, when it is dissociated, it will be 2Al. So 2 into 3, which is equal to 6. Are you getting my point? Are you getting my point? 1 Al will be, I'm just taking the charge on the cation only. So listen carefully, this will be Al2. Al2SO4 thrice means it will be dissociated and they will be forming in such a way that, how they will be forming, children? Al will be having 3 charges. Al 3 plus. Am I correct? Correct? Children, this will be dissociated as 2Al3 plus 3SO4 2 minus. Okay, this is the dissociation which is happening here. So, well, I'm just taking the particular charge of the Al only, which is the charge of the cation or anion, it will be same. So, 3 charges are there. How many L's are there? 2L. 2 into 3, 6. That is N is the 6 here. Are you getting my point, children? Or if you are taking the SO4 also, 2 minus SO4 as a whole, it is 2 minus 2 into 3, which is 6. That is also N. So, now here there is an exceptions. H3PO4, H3PO3 and H3PO2. Do you know what is the N here? Tell me the N here, children. Tell me the N here. Let me check whether any other exceptions are required for your syllabus. So, tell me the N here. As you know, one second, children. No, nothing else is there. This is only the H3PO4, H3PO3 and H3PO2. That is only required for you. So here, I don't want to write the, see this is actually N as of your knowledge, N is 3 here. Am I correct? N is 3, H3PO4. But in the H3PO3 and H3PO2, you will be thinking that N is equal to 3 here, N is equal to again 3 here. This is wrong. N is equal to 2 here, N is equal to 1 here. This is one exception. You have to get it. No, H3PO4, H3PO3 and H3PO2 acids. N is 3 H3PO4, H3PO3 N is 2, then H3PO2 N is 1. You don't, that is actually you are studying in the P block elements. It is due to the structure of them. So that is the reason. Just right now, just as of now, you just learn it like this. Okay. Even in the boric acid also it comes like the same. Okay. Now, parts per billion, parts per million. Parts per million is actually weight of the solute divided by the weight of the solution, just like the volume by, mass by mass percentage was there, na? Done in denominator it was solution and into 10 raised to 6. So, parts per million means basically, எப்படி சொல்றது, ஒரு million parts of solution எடுத்துட்டேன்னா அதில் எவ்வளோ amount of the number of solute which is present in the 1 million portion or 1 million parts of solution எடுத்துட்டேன்னா அதில் எவ்வளோ solute இருக்கு, அதுதான் parts per million சொல்றது. Are you getting my point, children? Are you getting my points? I repeat, the number of parts of solute present in the 1 million part of the solution is called as the parts per million. So, number of solute divided by mole. So, we can say that parts per million in terms of volume by volume, not volume by volume, children, mass by mass, mass by volume and moles basis. So everything will be solute by solution only. See, when the weight of the solute divided by the volume of the solution, since you are taking it in the weight, mass bar volume. Here moles of the solute divided by moles of the solution into 10 raised to 6. I hope this is clear for everyone, correct? Clear now? Okay. Now mole fraction we didn't done now. Okay. So, mole fraction which is chi. So, mole fraction is basically, mole fraction is the amount, it's a ratio between the moles, right? Mole fraction means the ratio of the number of moles of particles. See, it's the ratio of the number of moles of a particle component to the total number of the moles. For example, if we have, I know you know this. You have a container here. Okay, you have a container A plus B. You have, so mole fraction of Na or mole fraction of A is equal to mole fraction of, what is happening here? Mole fraction of A is equal to number of molecules of that particular component, which is Na here, divided by the total number of moles, which is Na plus Nb. Are you getting my point, children? Or else if you are taking it as a molecules like, my drawing skill is very bad, I guess, especially when it comes to the board. Small letter N and big letter N. So, okay, this is something called as the mole fraction. Always remember that chi of solute, always remember chi of solute any particles here I'm just taking நான் வந்து ரெண்டு particles மட்டும் தான் சொல்றாங்க அதனால ரெண்டு particles எடுத்துருக்காங்க always remember the chi of mole fraction of any substance or any particles in that particular solution will be always equal to 1 clear this is also a very important point you have to know this is also a very important point okay you will do a lot of this particular point is coming in the a lot of things like you will be doing a lot of questions in the derivations also okay now solubility of the gas in liquids we are going to the see children let me tell you one more thing இதில் நான் இப்போ சொல்ல போகிற சில டாபிக்ஸ் எல்லாம் உங்களுக்கு இருக்காது பட் அந்த டாபிக்ஸ் எடுத்தால் தான் இன்னும் டிஃபிகல்ட்டாக இருக்கிற டாபிக்ஸ் உங்களுக்கு இன்னும் ஈஸியாக புரியும் ஸோ அதனால தான் ஐம் டெல்லிங் a lot of topics I mean which is like little நீங்கள் நினைப்பீங்க இதெல்லாம் டெக்ஸ்டில் இல்லைங்களே இந்த தான் கொஞ்சம் தான் கொடுத்துருக்காங்க ஏன் இவ்வளோ எக்ஸ்பிளைன் பண்ணுறாங்க உங்களுக்கு அந்த ஐடியா கிடைக்கிறதுக்காக மட்டும்தான் சரிங்களா ஓகே ஸோ solubility of the gas in liquid கேஸை வந்து லிக்விடில் soluble ஆக்குறதுனா carbonated drinks and all right so solubility of the substance its maximum amount that can be dissolved in the amount a specified amount of the solvent maybe we will be taking 100 grams of the solvent and what is the amount of the solute which is dissolved in this 100 grams of the solvent that is basically the solubility saturated solution we will be saying they will be getting a or they will be forming a saturated solution at particular temperature am I correct that is something called as the solubility right or wrong yes now solubility of one substance into another depends upon the ஒரு இப்போ ஒரு substanceல இன்னொரு substance எப்படி soluble ஆகுதுன்னு of course they depends upon the nature of that particular substance temperature and the pressure what are the three factors nature of that particular solvent and the gas here since we are discussing about the gas in solvent na so liquid and the gas what is the nature of that particular liquid and what is the nature of that particular gas it depends upon that and the pressure and the temperature I hope this is clear for you children now where is the remote okay now nature of the solvent and the gas so there is one thing which is called as polar gases dissolve in the polar solvent and non-polar gases dissolve in the non-polar solvents like dissolves like for example polar what is mean by polar what do you mean by polar means they do have a charge separation irukku for example H2O they have a charge separation H plus and OH minus that is actually polar substance non-polar ones means they don't have the charge separation benzene then CCl4 all these are example for the non-polars so polar இருக்கிற solute வந்து NaCl அது வந்து polar solventல தான் dissolve ஆயிடும் are you getting my point polar gases okay இப்போ gases வந்து polar gases example தான் நான் சொன்னேன் polar gases வந்து they will be dissolving in the polar solvents and non-polar gases will be dissolving in the non-polar solvent when a gas undergo the ionization in a solvent then it is highly soluble in that solvent ionization means split பண்றாங்க for example HCl gas ஆ இருந்தா H plus Cl minus ஆக split பண்ண முடிஞ்சதுச்சுனா அந்த gas will be very highly soluble and see that's why HCl is highly soluble in the water is a non-polar one okay now temperature effect எப்பவுமே யோசிச்சுக்கோங்க லிக்விட்ல எல்லாம் இப்போ நம்ம ஒரு பீக்கர் எடுத்து அதில் கொஞ்சம் லிக்விட் வச்சு ஒரு வாட்டர் ஏதோ வச்சு நம்ம கேஸ் ஸ்டவ்வில் வச்சு நம்ம we will be increasing the temperature then the solubility will be increasing நம்ம ஒன்றும் இல்லைடா ஒரு பீக்கர் எடுத்து நம்ம தண்ணி அதில் ஊற்றிட்டு கேஸ் சிலிண்டரில் கேஸில் வச்சுட்டோம் அதில் இந்த சுகர் போடுறதுக்கு முன்னாடி we just make them to boil பண்ணிட்டேன்னா அதோட டெம்பரேச்சர் இன்க்ரீஸ் ஆகிட்டு அதுக்கப்புறம் நம்ம சுகர் போடுறேன்னா it will be like they will be dissolving very fastly am I correct ஆமாம் தானே it will be dissolving very fastly but in the case of gas in liquids they are different case temperature increase ஆகும்போது solubility decrease தான் ஆகும் see liquid solid வரும்போது நம்ம temperature increase ஆயிட்டேன்னா solubility increase ஆகுது அதனால தான் அந்த sugar வந்து ஈஸியாக dissolve ஆகுது but in the case of gas in liquid when we increase the temperature the solubility is decreasing solubility of the gas increases with the decrease of temperature or else we can say that is inversely proportional that is the reason why carbonated drinks this can ask in the question carbonated drinks எல்லாம் எதுல வச்சிருக்காங்க they will be adding this particular அந்த ஒரு gas இருக்குள்ள low temperatureல தான் வச்சிருப்பாங்க okay so the solubility of the gas increases with the decrease in the temperature. It is due to this reason that aquatic species are more comfortable in the cold water rather than in the warm water. This is the same reason why we will be telling like they will be like warm water and then there is less dissolved gases, so there is a chance of dying also, right? And oxygen dissolved into a small excess in the water. It is this dissolved oxygen which sustains all the aquatic life. That is generally now dissolution. Okay, now idhula innor vishayam enna oru gas vandu oru liquid dissolve agrena, that is a highly exothermic process. What is exothermic process? Heat is liberated. Heat is liberated. So temperature increase ஆகும்போது எப்பவுமே என்னதா இருக்கும், solubility decrease ஆகும். This is a very important point. Take a note of it. Okay. Next one is now in ஒரு பெரிய ஒரு கான்செப்ட்லேக்கு தான் நம்ம வர போகிறோம். ஹென்ரி லோ சொல்கிறது இட்ஸ் நத்திங் தட்ஸ் டிபெண்ட்ஸ் அப்பான் திஸ் பர்டிகுலர் solubility only. ஒரு கேஸோட இன் லிக்விட்ல இருக்கிற solubility சொல்கிறது இட்ஸ் directly proportional to the partial pressure in அந்த கேஸ் டிசால்வ் ஆயிருக்குல அந்த லிக்விட்ல இருக்கிற பார்ஷியல் ப்ரெஷருக்கு directly proportional. So I'm telling you the solubility of the gas in a liquid at a given temperature is directly proportional to the partial pressure at which it is dissolved. What do you mean by the partial pressure, vapor pressure and all? Partial pressure என்ன, vapor pressure என்ன? ஏன் partial pressure சொல்றாங்க? Any idea children? இதுல வருதா? Just a second. Partial pressure and vapor pressure. See, partial pressure சொல்றது ஒரு பர்டிகுலர் கண்டெய்னர்ல நிறைய கேஸஸ் இருக்குன்னு வச்சுக்கோங்களேன். A and B இருக்கிற கேஸஸ் இருந்தேன்னா அதுல A அந்த ஹோல் கண்டெய்னர்ல வச்சு ஏயோட மட்டும் கேஸை நம்ம சொல்றேன்னா அது partial pressure of A with respect to or in the mixture of A and B. Partial pressure of B in the mixture of A and B. That is the difference between the partial pressure. Partial pressure, vapor pressure means just like நார்மல் ஒரு கண்டெய்னர்ல இருக்கிற ஒரு ஏ இருக்கிற கேஸோட ப்ரெஷர் தான் வேப்பர் ப்ரெஷர் சொல்றது. பி இருக்கிற கண்டெய்னர்ல ஓகே ஐ வில் டு ஒன் திங். லிசன் கேர்ஃபுல்லி சில்ட்ரன். ஐயோ, this is a beaker, this is another beaker, this is another beaker. This is beaker A, this is okay beaker A, and they do have the pressure gas and PA. This is our beaker B and they do have it. Okay, this is B and this is our beaker, not C children. Okay, this is our beaker A plus B, which means they will be, of course, they will go to have, this one will be there. இந்த கணக்கு தான் நான் யூஸ் பண்ணும். This also will be there. So what I want to tell you student, so இது வந்து vapor pressure. இந்த particular liquid exert பண்ற pressure தான் vapor pressure சொல்றது. இந்த particular liquid வந்து exert பண்ற pressure தான் vapor pressure சொல்றது. Vapor pressure of B. இங்க ரெண்டுமே சேர்ந்து இருக்கும்போது we can say that partial pressure of B or partial pressure of A. So partial pressure of A is the pressure of the A which is in the solution of A and B. Partial pressure of B or partial pressure of B means B ஓட pressure தான் அந்த solutionல இருக்கிற AB ல இருக்கிற B ஓட pressure செப்பரேட்டா நம்ம சொல்றதா partial pressure சொல்றது. So what was Henry Law's is, Henry Law states that the solubility of the gas in a liquid is directly proportional to the partial pressure of which it is dissolved. Or else we can also tell, I'm just rubbing this, we can also say it in such a way that, listen carefully everyone, we can also say it in such a way that the partial pressure of the gas in the partial pressure of the gas in the vapor phase is directly proportional to the mole fraction of the gas. So whenever there is a partial pressure, that particular gas which is in the and ஒரு liquid வந்து அது ஒரு vapor phaseல reach ஆகும்போது அந்த particular vaporோட partial pressure சொல்றது எதோட ஈக்குவலா இருக்கும், mole fraction of the gas ஓட ஈக்குவலா இருக்கும். இப்போ நம்ம ஒரு சொல்யூஷன் சொல்யூஷன் எடுத்துட்டேன்னு வச்சுக்கோங்களேன், அதுல ஒரு கேஸ் இருந்ததுன்னு வச்சுக்கோங்களேன், அந்த கேஸ்ல ஒரு சொல்யூஷன்ல நிறைய there is a lot of gases, and the partial pressure of that particular gas in the vapor phase is directly proportional to the mole fraction. So mole fraction solumbodhu we can say that mole fraction, see, partial pressure is directly proportional to the, I will write here, partial pressure is directly proportional to the mole fraction. And in order to remove this proportionality, we are giving you a constant. This is actually called as the Henry's law constant. This is Henry's law constant. Okay, P is the partial pressure of the gas in the equilibrium with the solution. Equilibrium means and the solution la eppadi solradhu, அந்த லிக்விட் ஃபேஸும் கேஸ் இருக்கும்ல, அதோட அந்த equilibrium தான் equilibrium அந்த சொல்யூஷனில் சொல்கிறது. கேஸ் இந்த equilibrium with the solution. அந்த லிக்விட்லையும் கேஸ் இருந்து தான் நம்ம சொல்ல போகிறோம், ரைட்? வி ஆர் டிஸ்கஸிங் லிக்விட் அண்ட் கேஸ்னா அது ரெண்டுமே ஒரு equilibriumத்தில் வரும்போது தான் என்ன சொல்கிறது, partial pressure of the gas in equilibrium with the solution. KH is the Henry's law constant and a chi is the mole fraction of the unreacted gas in the solution. Now this is what I want to tell you. See, this is a liquid is there, now gas is there, right? This is liquid and this is gas, right? Now நம்ம pressure கொடுக்கும்போது என்ன ஆகுற, when we are applying the pressure, see what happens when we increase the pressure, solubility, that particular gas is actually soluble, right? When we are applying the pressure, that's why we are telling like pressure is inversely proportional to the solubility. When we increase the pressure, solubility also increases. So when we decrease the pressure, what happens, they becomes into two layers, they are not soluble. So whenever the pressure increases, solubility increases. This is in the case of gas and liquid. Next point is temperature decreases, solubility increases. These are the 2 points. So that is the things. Now comes the Henry's law applications. நிறைய okay, first of all characteristics க்கு போயிட்டு அப்புறம் application போலாம். Characteristics means they have the same pressure or unit, that torr or bar, whatever it is, and they have different gases will be having different value of Henry law constant for the same solvent எடுத்தாலும் அதோட gas different ஆகும்போது they will be having different value, and KH value of the gas different in the different solvent. So different solvent எடுத்தாலும் different gases will be having different KH for the same solvent, and the KH value of the gas is different on the different solvent also. Now KH value increases with increase in the temperature. Temperature increase ஆகும்போது KH value increase ஆகுற. So KH value increase ஆகுறன்னு சொல்லும்போது what is happening to the solubility? What is happening to the solubility, children? Tell me. I repeat, KH value increase ஆகும்போது temperature increase ஆகுற. Temperature increase ஆகுறனா solubility decrease ஆகுற. This is our next point. Higher the value of the KH of the gas, lower will be that particular solubility of the gas. Okay, now Henry's law oda oru 1 second children. Henry's law oda graph da solla porom. Okay, so we know that, see, listen here we are giving that 1 second, see here engila. Okay, P is equal to, okay, I will write it there, that's much better. What was the equation? P is equal to KH chi. Am I correct? Okay. So Y is equal to mx. This is the graph, right? X is in the mole fraction, Y is in the partial pressure, and KH will be the slope. Okay, this is actually the particular graph. Now what happens means when we are increasing the temperature means this is the T1, this is the T2, and this is the value of the particular KH in the T1, T2, T3 temperature. So when the temperature increases, of course the value of the KH also is increasing. T1 is greater than T2 is greater than T3, and same thing happened for the KH1, KH2 and KH3. Clear everyone? Clear? So this is the graph of the Henry's law graph. You just have a look of this. More than this, that Raoult's law gas is graph is very important, not gas, graph. Now coming to the applications of the Henry's law. What are the applications? You have learned a lot of applications, and there are some applications which will be they will be frequently asking in the questions also. I'll tell you, please write down, please note it down in the special cases, okay? To increase the solubility of the CO2 in soft drinks and the soda water, the bottle is sealed under high pressure. So I told you, when the pressure increases, solubility increases. And the solubility increase ஆகிறதுக்கு, and the particular CO2 solubility increase ஆகிறதுக்கு, they are actually dissolving that in the higher pressure. That is the first one. At high altitude, this is important, okay. At high altitude, the partial pressure of the oxygen is less than that of the ground level. So, partial pressure, higher altitude la enna aidum, partial pressure pressure of the higher ku pogumbodum partial pressure of the oxygen is less, because partial pressure of the oxygen is less than at the ground level. This is also an application of the Henry law. Next one is scuba diving tanks are diluted with the helium. Why they are diluted with the helium? Why the scuba diving tanks are diluted with the helium? So they will be mixed with the oxygen, because adala vandu nammaloda blood la kedakra and helium vandu the ability to dissolve in the blood is less when compared to the other nitrogens and all. That's why we are using this particular, or the scuba divers are using this helium mixed with the oxygen. Next one is the scuba high concentration of dissolved gas while breathing at high temperature. Scuba divers must cope with the high concentration of dissolved gases while breathing air at high pressure. Increased pressure increase the solubility of the atmospheric gas in the blood, which can release even the diver comes towards the surface. So the pressure decreases and resulting in the formation of the nitrogen bubbles. So others stop pandradhukku da we will be doing it. Okay, the bubble blocks the capillaries and creates the medical condition known as bends, that is painful and dangerous to the life. So to avoid blends as well as the toxic effect of high concentration of nitrogen, they will be using that particular tanks will be filled with this particular helium also. This is the reason why they will be mixing with the helium. Next one is the Henry law. Now comes these were the applications. முன்னாடி சொன்னதெல்லாம் அப்ளிகேஷன்ஸ் தான். இப்போ வந்து லிமிட்டேஷன் சொல்கிறாங்க. ஹென்ரிஸ் லோவோட ஃபர்ஸ்ட் லிமிட்டேஷன்ஸ் என்னன்னா, ப்ரெஷர் ஆஃப் த கேஸ் வந்து ஓகே இட்ஸ் நாட் டூ ஹை. See, Henry law எப்போ வேலிட் ஆகிடும்னா, வேலிட் ஒன்லி அண்டர் த ஃபாலோயிங் கண்டிஷன் that the pressure of the gas is not too high. ரொம்ப ஹையாக இருக்கக்கூடாது, டெம்பரேச்சரும் வந்து ரொம்ப லோவாக இருக்கக்கூடாது. அதே மாதிரி ஒரு அந்த கேஸ் வந்து அந்த dissolve ஆகிற கேஸ் இருக்குல்ல, பர்டிகுலர் சொல்யூஷன் சால்வெண்ட்டில் we can say the gas is solute na. So சால்வெண்ட்டில் dissolve ஆகிற கேஸ் வந்து they shouldn't undergo any chemical reaction, they shouldn't mix together, they shouldn't undergo chemical reaction. அவங்க அந்த ஒரு chemical reaction ஆகாமல் இருந்தால் மட்டும்தான் இந்த Henry's law they are applicable. And the gas should not undergo the dissociation also. See, even with the solvent they do not undergo the dissociation. For example, H plus L minus R dissociation ஆகக்கூடாது. These are the situations where the Henry's law is applicable, and this is actually the limitations of the Henry's law also. Now coming to the, so we have as far now நம்ம இதெல்லாம் படிச்சிட்டோம், concentration terms பற்றி படிச்சிட்டோம், and we discussed about the solubility, and there we discussed the Henry's law graph discuss பண்ணோம், அதோட applications பார்த்தோம். We discussed about the characteristics of the Henry's law, then we also discussed about the limitations of the Henry law, right? Now we are going to look into the vapor pressure. Do you know what is the vapor pressure? Any idea about the vapor pressure? Ma'am, இங்கே எழுதிருக்காங்க மேம், some of the more energetic particles on the surface of the liquid must enough to escape from the attractive force of holding the liquid together. As the gas particles bounce higher, some of the sit in the surface of the liquid, it's trapped there. Okay, so what is vapor pressure? Children, I'll tell you one thing. ஒரு பீக்கரில் நீங்கள் தண்ணி எடுத்துக்கோங்க, அந்த தண்ணி வந்து நீங்கள் ஒரு 4 நாளுக்கு அப்புறம் ஒரு இடத்துல வச்சுக்கோங்க, ஒரு 4 நாளுக்கு அப்புறம் பார்த்தேன்னா there won't be water in that. Am I correct? That water is actually evaporated, which is in the liquid state of the water is going to the gaseous state. So whenever they are or closed container varumbodhu and the liquid state of the water they are going to the gaseous state now. So what happens means that particular vapor, okay, when that particular phase transfer ஆகும்போது அந்த வேப்பர் ஃபேஸில் இருக்கிற ஒரு ப்ரெஷர், அந்த ப்ரெஷரை தான் என்ன சொல்கிறது, வேப்பர் ப்ரெஷர் சொல்கிறது. ஸோ ஐ வில் டெல் யூ, see some of the more energetic particles on the surface of the liquid move fast enough to escape from the attractive force. You know that they will be having an attractive force between the liquids, and the liquidோட attractive force, see, so basically this is the liquid of yours, okay, and they will be going into the vapor. So there will be a pressure which is exerted by this vapor. That pressure is actually the vapor pressure. They will be, இது எப்படி போகுவாங்க, அந்த லிக்விட் ஸ்டேட்ல இருக்கிற அந்த ஃபோர்ஸ் ஆஃப் அட்ராக்ஷன் பிரேக் பண்ணிட்டு போகிறதா வேப்பர் ப்ரெஷர் சொல்றது. As the gaseous particles bounce around, some of them will the heat of the liquid again and they will be trapped there. That is actually comes under the category of the vapor pressure. And now I want you to note it down. This is very important in this. See, always remember, gas plus liquid. என்னடா இது, எனக்கு எத்தவும் மாட்டேங்குதே. Gas plus liquid நம்ம எதை பத்தி டிஸ்கஸ் பண்ணோம்? We discussed about the Henry law, right? Henry lawல நம்ம gas plus liquid பத்தி தான் டிஸ்கஸ் பண்ணோம். Liquid plus liquid வரும்போது we are going to discuss that is actually Rod's law. Rod's law we are going to discuss. Now solid plus liquid or solid add பண்ற ஸ்டேஜ்ல colligative property வருது. I repeat, gas liquidல gas add பண்ணும்போது தான் Henry law relate ஆகுது. Liquidல liquid add பண்ணும்போது தான் Rod's law liquid relate ஆகுது. Liquidல solid relate add பண்ணும்போது தான் colligative properties வருது. This is actually a note, like ஒரு ஐடியா கிடைக்கிறதுக்கு, ஹென்ரி லோ, ராட்ஸ் லோ எல்லாம் கன்ஃபியூஸ் பண்ணாம இருக்கிறதுக்கு. ஓகே, ஸோ வேப்பர் pressure means the pressure exerted by the vapor on the solvent A and the solute B in the equilibrium with the liquid phase. See, vapor pressure நான் ஒரு வேப்பர் ப்ரெஷரோட மட்டும் தான் சொல்றேன். இது A and B அவங்க சொல்லிருக்காங்க. That is coming next. As of now, you just listen to me. Vapor pressure சொல்றது it is a pressure exerted by a vapor. Okay, when அந்த liquid stateல இருந்து gaseous stateக்கு போகும்போது அங்க ஒரு pressure வரும். அந்த pressure which is exerted by a vapor. So அந்த particular solutionலயோ இல்ல liquidலயோ வர அந்த ஒரு particular vapor exert பண்ற pressure தான் என்ன சொல்றது, vapor pressure சொல்றது. Now it depends upon the nature of the liquids. One second, did I miss? Okay, this is not required for you. Okay. Now vapor pressure depends upon the nature of the. See, whenever there is the intermolecular force of attraction as decreases. For example, you have a liquid and they have the less intermolecular force of attraction. Water and honey. Honey is having more. Water is having less. So, adula the vapor pressure என்னதா இருக்கும்? More vapor pressure இருக்கும். They can change to vapor phase very fastly. Which means அவங்களோட boiling point என்னதா இருக்கும்? Less இருக்கும். Ma'am, எப்படி ma'am boiling point less இருக்கும்? யோசிச்சுக்கோங்க. அந்த liquid வந்து gaseous stateக்கு ஈஸியா போக முடியுது. ஆமா தானே, அதனால தான் vapor pressure increase ஆகுது. They can easily go into the volatile. They can easily go into the vapor phase very fastly, right? So vapor phaseக்கு சீக்கிரமா போக முடியறனா அவங்களோட boiling point என்னதா இருக்கும்? Listen carefully children. They have the two boiling points are there. ஒன்னு வந்து 100 degree Celsiusல boil ஆயிடும். ஒன்னு வந்து 50 degree Celsiusல boil ஆயிடும். ரெண்டு liquids நான் எடுத்துர்க்கேன். Listen carefully. This is very important. One second. I have taken A and I have another liquid which is B. Okay, consider boiling point of this is 50%, 50 degrees Celsius, and this is 100 degrees Celsius. So tell me which one is more volatile? More volatile will be A, which means boiling point increase ஆகுறேனா, boiling point is increases, vapor pressure increase, sorry, I will tell you, one second. Boiling point vapor pressure increase ஆகுறேனா, vapor pressure வச்சு கனெக்ட் பண்ணலாம். vapor pressure increase ஆகுறேனா, vapor pressureனா liquid phaseல இருக்கிறது vapor phaseக்கு போகும்போது அந்த between that H2O, for example H2O liquidா இருந்தது, H2O gasஆ போகும்போது, அதாவது H2O liquid, this H2O which is in the liquid state and which is the H2O which is in the gaseous state, they will be having an equilibrium and there will be having the pressure, that pressure exerted by this particular gas which is called as the vapor pressure. Am I correct? Now I want you to know that when the vapor pressure increases, okay, when the vapor pressure increases, what is happening to the boiling point? Children, vapor pressure increase ஆகுறேனா liquid state ல இருந்து gaseous state க்கு சீக்கிரமா போக முடியும். அப்ப boiling point க்கு என்னதா இருக்கும்? Boiling point has to be less. Am I correct? Boiling point has to be less. For example, இங்க 50 degree Celsius 100 degree Celsius கொடுத்திருக்கேனா 50 degree Celsius ல தான் boiling point கம்மியா இருக்கு, which means they will easily go to the vapor state, which means அவங்களோட vapor pressure ரொம்ப ஸ்பீடா இருக்கும். They don't have any molecules to suppress them, right? அந்த molecules ஓட attraction force ன்னு சொல்றது ரொம்ப கம்மியா இருக்கும். இங்க இன்னும் கொஞ்சம் அதிகமா இருந்தானா they require more time. Are you getting my point? See, it depends upon when the intermolecular force of attraction less இருந்தேனா vapor pressure more இருக்கும், அதோட boiling point will be less. Loosely held molecules escape more easily into the vapor phase. That is Now, boiling point. So, what is boiling point? The point or the temperature at which the liquid start boiling, right? The temperature at which we can say that vapor pressure or the vapor pressure of the liquid is equal to the external pressure. Listen carefully. This is your liquid, okay, and I boiled it, okay. There will be some vapor pressure which is going through this. This is from this pressure, and of course there will be pressure which is external pressure will be the, when this particular external pressure and the vapor pressure, when they becomes equal, the liquid starts to boil. Are you getting my point? Children, இப்போ நீங்கள் என்ன மேம் எப்பவுமே கீழே பார்க்குறீங்க, நான் அந்த வீடியோன்னு சொல்லியிருக்கேன். கீழே பார்க்குறது என்னென்னா, என்னையே வந்து எனக்கு இங்கே கீழே அந்த மானிட்டரில் தெரியும். ஸோ ஐ ஜஸ்ட் வாண்ட் டு நோ தட் நான் வரைச்சது கரெக்டாக தெரியுதா, எனக்கு இங்கேருந்து பார்க்கும்போது ஓகே இருக்கு, ஆனால் உங்களுக்கு எப்படி பார்க்குறதுன்னு கரெக்டாக இருக்கணும்ல, அதனால தான் நான் அப்படி பார்க்குறேன். ஓகே, ஸோ ப்ரெஷர். ஸோ திஸ் இஸ் ஆக்சுவலி the vapor pressure which is going from this particular liquid. When this particular vapor pressure is equal to the external pressure, that is actually when the liquid starts to boil. That is actually the boiling point. So normal boiling point la vapor pressure of a pure solvent or a pure liquid இருக்கும்போது எப்பவுமே 1 atm தான் இருக்கும். Clear? Now more molecules from the, listen carefully, temperature increase ஆகும்போது vapor pressure க்கு என்ன ஆகும்? Temperature is easy one. Temperature increase ஆகும்போது liquids வந்து அந்த kinetic energy increase ஆகும். Kinetic energy increase ஆகுற means they can easily see, listen, see this is that one, when the temperature increases, kinetic energy increases, they started to go to the vapor state very fastly. They started, this is a closed container, they started to go to the vapor state very fastly, and when this vapor state comes into the equal to the pressure external, they started to boil. Are you getting my point? So whenever the temperature increases, vapor pressure also increases. How the vapor pressure increases? Kinetic energy of the particles increases and the vapor pressure increases. Now Rolle's law. Now, so we have done with the vapor pressure, we have done with the Henry law, we have done with the vapor pressure, then we are going to the Rolle's law. Rolle's law is liquid one, right? Listen carefully, Rolle's law is little நல்லா listen பண்ணியிருந்தா தான் உங்களுக்கு நல்லா புரியும். Okay, listen carefully. So, in the solution of a volatile liquids means the liquids which is undergoing the volatile state, which is undergoing the vapor phase very fastly. So, the partial vapor pressure of each component is directly proportional to the mole fraction of in that liquid state. And the liquid state la இருக்கிற இப்போ நிறைய liquid இருந்ததுன்னு சொன்னேன்ல, liquid தான் vapor Henry law, I mean not Henry law, Rolle's law சொன்னேன். So, ரெண்டு A and B இருக்கிறேன்னா, ஏயோட பார்ஷியல் ஸ்டேட்ல சொல்றது, ஏயோட பார்ஷியல் ப்ரெஷர் சொல்றது எதா இருக்குன்னு சொல்றாங்க, மோல் ஃபிராக்ஷன் ஆஃப் தட் பர்டிகுலர் சப்ஸ்டன்ஸ். ஸோ one second. This we have discussed. PA plus PB is equal to okay, I have to discuss it. So partial vapor pressure of each component is directly proportional to mole fraction in the liquid state. And the component oda mole fraction ku equal ah irukku solranga. See, for example, you have, can you see this one? No, one second. You have your PA, partial pressure PA. Okay, or else I will give you one thing, children. One second. I will add a slide here. This is much better. This is A. Okay, this is B. Okay, now this is the pressure of A. This is the pressure of B. It's pure A. Nothing is there. That's why P not A. Pure A. Nothing is there. Now, I'm adding the both two. And I got A plus B. So, this is the total pressure. P total is equal to partial pressure of A plus PA plus PB. Am I correct? This is what I written here. PA plus PB. So, now, I want you to know once again. So, PA plus PB. Partial pressure of A is equal to pure அந்த பியூரா இருந்தது, இது போ லிக்விடா இருக்கு, லிக்விடா இருந்தது, இது பியூர் ஸ்டேட்ல இருந்தது, ஜஸ்ட் திஸ் இது மட்டும் தான் இருந்தது, ஏ மட்டும் இருக்கிற லிக்விட் இருந்தது, பி மட்டும் இருக்கிற லிக்விட் இருந்தது, ரெண்டு ஒருத்தர் மிக்ஸ் இருந்தது. மிக்ஸ்ல தான் நாம சொல்றோம் பார்ஷியல் பிரஷர் சொல்றது, இதை டினோட் பண்ணி பார்ஷியல் பிரஷர் இஸ் ஈக்குவல் டு அந்த பியூர் ஏ இருக்குல்ல, எந்தோட பியூர், இதுல இருக்கிற பியூர் ஏ into mole fraction. Are you getting my point? Now partial pressure of B is equal to pure B into mole fraction of B. Now total pressure P total is equal to P naught A into chi A plus P naught B into chi B. Are you getting my point, children? This is also Rolle's law. Okay, this is also Rolle's law. These are the different Rolle's law. I mean different definitions for the Rolle's law. Are you getting my point, children? Are you getting my point? Here that's they have given here. Clear? Okay. So for binary solutions, this is what we have discussed. P total is equal to, that is something called as the Rolle's law. See here, listen carefully. A and B was there, A is there, B is there, that is chi A, chi B, correct? Now we are adding like P naught, partial pressure of B is equal to the partial pressure of P naught B, which is the pure one. பியூரா இருந்ததுல சொல்யூஷனா இருக்கு, நம்ம பார்ஷியல் பிரஷர் ஆஃப் பி சொல்றது சொல்யூஷன்ல இருக்கிற பார்ஷியல் பிரஷர் ஆஃப் பி நம்ம கண்டுபிடிக்கிறோம், ஆமா தானே? அந்த பார்ஷியல் பிரஷர் ஆஃப் பி சொல்றது பியூர் பியோட பிரஷர் இன்டு chi b. Are you getting my by chi b from here? Clear? Are you getting my point? Okay, so this is how the partial pressure solution which obey Rolle's law over the entire region of concentration is called as the ideal solution. அந்த ஒரு மொத்தமா அந்த ஒரு பீக்கர்ல solution which is obeying this particular Rolle's law is called as the ideal solution. We will discuss about it. Okay, so now I just want you to இந்த ஒரு விஷயம் இப்ப சொல்றதா, this is the same thing which we are discussing here also, na? Okay, here I will tell you. Listen carefully. I have written this equation already. One more time, I will write it down for you guys. Okay, so I told you know that, children, you know that chi A plus chi B is equal to 1. Correct? Chi A plus chi B is equal to 1. From there, chi B is equal to 1 minus chi A. Correct? And you already know that partial pressure, total pressure, P total, this one, P total is equal to P naught A chi A plus P naught B chi B. Now, I am giving this particular value of the chi B here. So, it will be P naught A chi A plus P naught B 1 minus chi A. Are you getting my point, children? Are you getting my point? Okay. Now, P naught A chi A plus, one second. Why I'm writing this again now? I forgot to delete that. So that's why I'm just writing it. Now, one second. P naught A chi A plus P naught B chi B minus P naught B. எப்படி மேம் வந்தீங்க? ஒன்றும் இல்லடா, இது வந்து ஃபர்ஸ்ட் எழுதுறதுக்கு பதிலாக இது லாஸ்ட் எழுதிட்டேன், அவ்வளோதான். எனக்கு வந்து இந்த கை ஏ கை பின்னு இருக்குல்ல. ஓகே ஒன் செகண்ட் ஹியர். ஒரே நிமிஷம். வேறு ஏதாவது மிஸ் பண்ணிட்டாங்களா? ஓகே, இது வந்து இந்த கையேன்னு இருக்குல்ல, அது எனக்கு சேமாக கிடைக்கணும் இன் ஆர்டர் டு அந்த காமன் டேர்மாக வெளியே இருக்கிறதுக்கு. ஓகே, ஸோ பார்ஷியல் ப்ரெஷர், டோட்டல் ப்ரெஷர் இஸ் ஈக்குவல் டு கைஏ இன்டு P naught A plus pure solvent B minus pure solvent B. Clear? Clear everyone? Any doubts on this? Clear? இதுதான் என்ன சொல்றது, இதுவும் வெப்ப ப்ரெஷரோட, ஐ மீன் ரோல்ஸ் லோட ஒரு இக்குவேஷன் தான். we are deriving it. Now உங்களுக்கு தெரியும் மேம் இது எப்படி மேம் ஞாபகத்தில் வச்சுக்கிறது ஒரு வழி சொல்கிறேன். இங்கே பாருங்களேன், PT is equal to P total pressure is equal to P, இது நீங்கள் படிச்சுக்கோங்க. P total pressure is equal to, இதை வந்து அரேஞ்ச் பண்ணி எழுதியிருக்கேன். ஃபர்ஸ்ட் P0, இந்த P0 minus chi into PB P0 minus P0. இனி இதில் எழுதும்போது எப்படி எழுதுறீங்கன்னா, you can write PB here, A here, AB. See, எழுதும்போது இங்கே B எழுதுவீங்க, இங்கே A எழுதுவீங்க, இங்கே A எழுதுவீங்க, இங்கே B எழுதிக்கோங்க. One second. Somewhere this equation is wrong. Plus வருங்க. Clear everyone? Clear? Is this clear? Okay. Okay. Now PT. Okay. In the graph, I will draw the. I will tell you how the graph will be coming. On the Rolls-Royce graph நம்ம ideal equation பார்க்குறோம். So that's why I'm not going this one as of now. Okay. இங்கே ஒரு பாயிண்ட் இருக்கு. This is not required for you children. இது வேணாம். This is not required. I will give you the graphs which is required for you. Okay. Easy understand பண்ணுறதுக்கு. இங்கே see, whenever partial pressure of A is greater than the partial pressure of pure A. Pressure of A, that is pure A, is greater than pure B, means which one will be more volatile? A will be more volatile, which means they can undergo to the higher state or they can undergo to the vapor state very fastly. That's why the pressure is more, right? Okay, that means pressure A more இருக்கும்போது அதோட boiling point என்னதா இருக்கும், கம்மியா இருக்கும். They can boil at lower temperature also. Clear everyone? Clear? This is another point. Now இப்போ mole fraction வந்து நம்ம liquid stateல தான் பார்த்தோம். நம்ம சொன்னோம்ல அந்த ஒரு graph இருந்தது, like here we were having this particular graphs now. One second. Where was that graph? Here we were having that graph now. One second. Where is that graph? Graph இல்ல, அந்த ஒரு எங்கடா, ஒரு நிமிஷம். This one. See, இது வந்து liquid stateல தான் இருந்தது mole fraction. Now அந்த mole fraction நம்ம வந்து we are going to take into the gaseous state. What is the state? Gaseous state. எங்க போன ராசா? Okay, வந்துருச்சு. Okay, so mole fraction of this vapor, gaseous state means vapor phase. Okay, so எப்பவுமே யோசிச்சுக்கோங்க, கை A சொல்றது என்னதா இருந்தது, liquid phaseல இருக்கிறதா இருந்தது. YA, this one is actually known as the YA, is called as the vapor phase in the mole fraction of A in the vapor phase above the solution. This will be the instead of that chi we are writing it as in the Y. So same thing will be there. PA is equal to PT. This is wrong actually children. PA is equal to chi A P naught A. That is actually the Rolle's law. And this is now one more thing children. I have to add a point here. This is very important. This is not wrong according to the Dalton's law. So according to the, listen carefully, according to the Dalton's law, see, pressure of A is equal to the mole fraction of the A, which is in the gaseous state, into total pressure. This is the Dalton, what he was telling. Okay, in the vapor phase they are telling, and we already know this is actually the Rolle's law, total PA plus PB. Now from this, how can you get into this equation? Any idea children? See, YA is equal to, that is the mole fraction in the vapor phase, is equal to PA by PT. From this equation, we got into this equation. Now, PA is equal to, from the Rolle's law, we know that P naught A into chi A divided by PT means P total is equal to PA plus PB. Am I correct? So, PA is equal to P naught A into chi A, which is we have given here. PB is equal to P naught B into chi B, which is given here. This is from the Dalton's law, that is a vapor pressure. So we got it that they are telling like the partial pressure of A is in the vapor pressure into total pressure. So that from there we are getting this equation. Are you getting my point children? Are you getting my point? Okay. One more thing I want to add here is, just a second, let me check it. One more point I want to add here. Just make a note of it. I'll give the notes, okay? I'll give the notes of this particular chapter after completing. I mean, one shot. இப்போ உங்களுக்கு இது வந்து எப்போ வரும்னு எனக்கு தெரியாது. அது வந்ததுக்கப்புறம் நான் உங்களுக்கு நோட்ஸ் கொடுக்குறேன். I will give the notes in the subscription. I mean, on the description box, not subscription box. Description box. Okay, அவ்வளவுதான். அது போதும், அந்த equation மட்டும் போதும். Okay, clear everyone? So this is actually the vapor pressure. I mean, not vapor pressure, mole fraction of the particular A in the vapor phase. For example, if I'm telling you this is the gas and this was the liquids. Am I correct? This was the liquids. When it was in the liquid state, when it was in the liquid state, chi A and chi B. Am I correct? When it went to the gaseous state. This is your gas. My God. This is your gaseous state, means it will be clear, everyone? Clear? Okay. Now, ideal solution. So, ideal solution is the one which will be obeying the Rod's law. Rod's law obey பண்ற எல்லா சொல்யூஷன்ஸுமே அது எந்த concentration, not constant, concentrationல Rod's law obey பண்றது. What are the Rod's law, children? PA is equal to P naught A into chi A, P naught B is equal to P naught B into chi naught B. இதுதான் என்ன சொல்றது, Rod's law சொல்றது. இது வந்து என்னது? PA, this one. PA is equal to P naught A into chi A, and P total is equal to PA plus PB, which is P naught A into chi naught A, chi A minus plus P naught B into chi B. This is what's the Rod's law. So, அது follow பண்ற எல்லாருமே ideal solutions தான். Okay. Now, listen carefully. இதுதான் உங்களுக்கு graph தேவை இருக்குது. Okay. Listen carefully. So, I will draw the graph separately. I will draw the graph. One second. Okay. Okay. So, you know that PA is equal to P naught A into chi A. Am I correct? PA is equal to P naught A into chi A. Correct now? PA is equal to P naught A into chi A. So, now, while I'm drawing this graph, you can write it like this. Y is equal to mx. Correct? Y is equal to mx. Right now? Right. Now, I'm going to give you, for example, if, I'll give it right here. If chi A is equal to 0. Okay, this is the mole fraction. Okay, I write this first. This is the mole fraction, and this is your partial pressure. Even this is also your partial pressure. Okay, I'm just writing the both in the particular one. Okay, so chi A is equal to 0. Chi A is equal to 0. What will be your PA? PA is also equal to 0. Am I correct? If chi A is equal to 0, PA is equal to 0. So, this is equal to 0. I'm telling you. Okay. This was in the point of 0. Then it is going, and this chi A is equal to maximum amount is 1. Am I correct? Right or wrong? Amadana? Maximum chi A plus chi B is equal to 1. So, maximum amount of maximum value of chi A is equal to 1. Correct now? Right? So, if chi A is equal to 0 means PA also 0, there is no value. When the chi A increases and when they reaches, this is your P naught A. Correct? Am I correct? So, I'm telling you, my dear students, listen carefully. If chi A is equal to 1, P naught A is equal to 1. Am I correct? No. 1 second. Chi A is equal to 1 means PA is equal to P naught A. correct? Chi A is equal to 1 means PA is equal to P naught A. Right or wrong? Are you getting my point, children? Are you getting my point? So PA is equal to P naught A. That is what first one. That is chi A is equal to 0 and chi A is equal to 1. It's going and it reaches the P naught A. This has to be little more strand. கொஞ்சம் ஸ்டாண்டா வரைக்கணும். Okay. Now chi B same thing. Chi B 0 ஆகும்போது chi B 0 க்கு வந்து PB. Okay, I will write it. Chi B 0 ஆகும்போது PB is equal to, this is the equation, P naught. உங்களுக்கு இப்போ I mean if you are able to follow me, என்ன follow பண்ண முடிஞ்சிருச்சுன்னா உங்களுக்கு இதோட ஆன்சர் தெரிஞ்சிருக்கணும். Chi B 0 ஆகும்போது என்னதான் 0 ஆகும்? PB is equal to 0 because 0 into any number it is 0, right? Correct? Right or wrong? Now, so chi B is equal to, I will write with some other color, that is much better. Confuse I don't think. This is chi A is equal to 0 when the chi B is equal, I mean chi A is equal to 1. Now it is increasing and they reaches the point where P. என்னடா இது? ரொம்ப சென்சிட்டிவ் இந்த விஷயம். இது P naught A. PA is equal to P naught A. Am I correct? Clear? இது இன்னும் கொஞ்சம் பெருசா இருந்திருக்கும். ஐயோ முடியலப்பா சாமி. Okay. Now starting from chi B is equal to 0. Chi B, if chi B is 0 means what will be happen to the PB also? என்னடா? ஐயோ என்ன இது? Okay. Chi B is 0 means PB also 0. Chi B சொல்றது 1 ஆயிட்டேனா PB என்னதா இருக்கும்? P naught B ஆயிரும். ஆமாதானே? chi B 1 ஆயிட்டேனா maximum amount ஆயிட்டேனா PB equal to P naught B, right? So chi B is equal to 0. This point chi B equal to 1. This is P naught B. P naught B. Clear? Clear? Are you getting my point? Now, this is the P total which is PA plus PB. இதுதான் ரால்ஸ்லோட கிராஃப் சொல்றது. புரிஞ்சுதா எப்படின்னு? PA plus PB எப்படி வந்ததுன்னு? Clear everyone? Clear? This is here, this is mole fraction. Here it is mole fraction. நான் முன்னாடி எழுதிருந்தேன் அது மாஞ்சிருச்சு. Clear everyone? This is clear? Okay? Okay. Next one. So this is the Lord's law. And the graph நான் வரைக்காம இருக்கிறதுக்கு the reason. இந்த graph சொல்லி கொடுக்கிறது தான். Next one is the ideal solutions. So ideal solutions are the one which will be which will be obeying the Rolle's law at any concentration of the solution. For example, we can say that அவங்க ஒண்ணுமே பண்ண மாட்டீங்க. You guys are ideally sitting. You are not doing anything. You are not turning. You are not producing any energy. You guys are ideally sitting. Means their delta x mix is equal to 0 because there should be like ஏதாவது ஒரு enthalpy change இருக்கணும்ல. There is no enthalpy change for this when they are ideally sitting, right? So there is no enthalpy change when components ideally solutions are mixed. There is no change, nothing happens. Delta V mix is equal to 0. இப்போ 10 ml எடுத்துட்டு let's say delta இப்போ உங்களுக்கு ஒரு சொல்யூஷன் வந்து 10 ml எடுத்து இன்னொரு சொல்யூஷன் 10 ml எடுத்து ரெண்டையும் மிக்ஸ் பண்ணிட்டா 20 ஆயிடும். ஆனா உங்களுக்கு அந்த delta mx, listen carefully, A plus B gives AB. இது 10 எடுத்துட்டா இது 10 எடுத்துட்டீங்க, இது மொத்தமா 20 வந்துருச்சு. ஆமா தானே? இதுல டெல்டா V மிக்ஸ் சொல்லும்போது இது மைனஸ் இது ரெண்டும் தான் நீங்க சேர்ந்து பண்றீங்க. 20 minus 10 plus 10 which is 0. So delta V mix is equal to 0. 1 liter plus 1 liter 2 liter. There should be no change in the mixing in the volume also. So that's why they are not like, they are ideally sitting, they are not doing anything, ideally sitting, that's it. Okay, for example, n hexane and n heptane, see hexane heptane, there is no not much change between them, adala ideal solution da. Ethyl bromine and ethyl iodine, small changes than ever. That's all comes under the category of ideal solution. Benzene and toluene, chlorobenzene and bromobenzene. Like benzene is just like a six member ring. Adlo CH2 vandana toluene. Romba change varadadellame ideal solution. The rendume mix பண்ணும்போது there is no that much change. They are ideally sitting. Those are ideal solutions. Okay. Now non-ideal solutions சொல்லும்போது Rolle's law complete disobey பண்ற ஒரு category தான் non-ideal solutions சொல்றது. PA is not equal to P not B or chi B. PB is not equal to PB is not equal to P not B or chi B. Nothing. இது ஒண்ணுமே Rolle's law, இது எல்லாமே Rolle's law தான். 1 2 3 இது ஒண்ணுமே obey பண்ணாததா என்ன சொல்றது, non ideal solutions சொல்றது. So solution that does not obey Rolle's law in the entire range of concentration is called as the Rolle's non-ideal solution, not Rolle's law, non-ideal solution. So listen carefully. The force of attraction between A and A, I'll tell you what is this. Force of attraction between AA and BBE is different from the AB. Then A and B will form non-ideal solution. For example, I'll tell you. You have, this is your AA concentration. You have another beaker BB and they are co-forming you, and you have the AB. Okay. So the force of attraction of AA and BP is different. So this having different force of attraction, this having different texture, this having different one. So those one will be forming a solution which is completely different one. You are here. Okay, your friend is another one. She's your friend, but she's like little chilling guy. கொஞ்சம் வந்து படிக்க மாட்டேங்க, படிக்கிறதுன்னு இல்லை, அவங்க வந்து பேசிட்டே இருப்பாங்க. ஸோ அது ரெண்டுமே டிஃப்ரெண்ட் கேரக்டர்ஸ். அதில் நெட் ரிசல்ட் வந்து என்னதான் இருக்கும், நான் ஐடியலாக தான் இருக்கும். உங்களுக்கு ஐடியலாக இருக்க முடியாது. யூ கேனாட் பி கான்சன்ட்ரேட்டட், கரெக்ட்? ஸோ தட் இஸ் சம்திங் கால்ட் அஸ் தி நான் ஐடியல் சொல்யூஷன். த ஃபர்ஸ்ட் ஆஃப் அட்ராக்ஷன் வந்து ஃபர்ஸ்ட் ஒன்னோடதும் செகண்ட் ஒன்னோடதும் கம்ப்ளீட்லி டிஃப்ரெண்டாக இருக்கும் அதோட ரிசல்ட்டிங் சொல்யூஷனில். ஸோ தட் ஆப்வியஸ்லி தட் வில் பி கம்ஸ் அண்டர் த கேட்டகரி ஆஃப் நான் ஐடியல் சொல்யூஷன். மேபி ஃபர்ஸ்ட் ஆஃப் அட்ராக்ஷன் இன்க்ரீஸாக இருக்கலாம், மேபி ஃபர்ஸ்ட் ஆஃப் அட்ராக்ஷன் டிக்ரீஸாக இருக்கலாம். ஐ ரிப்பீட் மை டியர் ஸ்டூடெண்ட்ஸ், ஏஏபிபின்னு சொல்ற ரெண்டு சொல்யூஷனில் அவங்களோட ஃபர்ஸ்ட் ஆஃப் அட்ராக்ஷனும் அது ரெண்டு கூட மிக்ஸ் பண்ணி போட்டு கொடுக்குற சொல்யூஷனோட ஃபர்ஸ்ட் ஆஃப் அட்ராக்ஷனும் கம்ப்ளீட்லி டிஃப்ரெண்ட். ஸோ தட் இஸ் why they are called as non-ideal solution. That like difference சொல்றது, maybe they can be increase the force of attraction in the AB, they can be less in the force of attraction in the AB also. That is different scenarios which is positive and negative that I will tell you. அது அந்த ஒரு சினாரியோ தான் என்ன சொல்றது, நான் ஐடியல் சொல்யூஷன் சொல்றது. கிளியரா புரியுதா உங்களுக்கு ஏதாவது? ஓகே, ஸோ ரோல்ஸ் லா சொல்றது ஒபே பண்ண மாட்டாங்க. டெல்டா மிக்ஸ் இஸ் ஈக்குவல் டு நாட் ஈக்குவல் டு 0, டெல்டா வி மிக்ஸ் இஸ் நாட் ஈக்குவல் டு 0 பிகாஸ் they either may be greater also. மேபி ரெண்டு கூட மிக்ஸ் பண்ணும்போது வோல்யூம் சொல்கிறது 21 ஆகலாம், மேபி 19 ஆகலாம். ஸோ தேர் டெல்டா வி மிக்ஸ் இஸ் நாட் ஈக்குவல் டு 0 அண்ட் சேம் ஃபார் தி டெல்டா ஹெச் மிக்ஸ் ஈக்குவல் டு நாட் ஈக்குவல் டு 0. ஸோ தேர் இஸ் 2 type ஆஃப் டீவியேஷன். ஸோ வி காட் டு நோ தட் தே வர் ஆக்சுவலி இன் அ லைன், ரொம்ப பர்ஃபெக்டாக போயிட்டு இருந்தாங்க. திடீர்னு ஒன்றில் அந்த சைடு மாறிச்சு, இல்லைன்னா இந்த சைடு மாறிச்சு. Positive deviation and negative deviation. I'll tell you what is positive deviation and negative deviation, which is very important. So positive deviation also is there, negative deviation is also there. Okay. Positive deviation சொல்றது, the force of attraction between AA, BB is stronger than the AB, which means AB force of attraction is lesser than the AA and ABB. This is lesser. Which one is lesser, children? AB force, resulting on force of attraction கம்மியா இருக்கும்போது தான் positive deviation போவாங்க. Partial pressure of each component A and B is higher. See, அவங்களோட அட்ராக்ஷன் வந்து கம்மியா இருக்கும்போது யோசிச்சு பாருங்களேன், ஏபியோட அட்ராக்ஷன் கம்மியா இருக்கிறேன்னா, see, partial pressure of each component A and B is higher than that calculated from the Rolle's law. Observed one காட்டிலும் calculated one வந்து அவங்களோட ஹையா இருக்கும் because they have more force of attraction, right? Are you getting my point? So for partial pressure of each component A and B is higher than that of calculated from the Rolle's law. Rolle's law calculate பண்றதை விட higher partial pressure தான் positive deviationல இருக்கும். Are you getting my point, children? Are you getting my point? Now the total pressure over the solution is also higher than the solution if we are ideal. So solution partial pressure also will be higher. Partial pressure, in short we can say that partial pressure, not the vapor pressure, not the vapor pressure, don't confuse it with the vapor pressure. Partial pressure is higher when can calculated with this particular, when calculated with the positive deviation. Positive deviation நம்ம calculate பண்ணும்போது partial pressure தான் hierarchy AA and BB. Now AA and BB will விட C. Now just a second children, why this is not coming in. AB oda force of attraction is more than AA and BB. Idu adhigama irundana, okay, or weaker in the BB and ABB, AA. Adukku weaker irundana illa higher irundana, appo each component is lower, so partial pressure is lower because they force of attraction, correct? So that is actually also that when the negative deviation comes, the partial pressure is lower. This is the point you have to remember. When the positive deviation comes, the partial pressure is higher, AABB order. So the total pressure is lower than the ideal one. So what will be happening to the total pressure? Listen carefully. For the positive deviation, so we can say that, see, this is the positive deviation, so we can say that PA will be greater. Partial PA is more, correct? So there will be more value. P naught A will be more, or P naught A will be more. So P naught A will be more. Here the P naught A is more. Okay, PB is more, P naught B, and the resulting one is also more. Are you getting my point? Higher level when the vapor pressure of the solution also increases when the partial pressure increases now. So here what happens? It decreases. This is the decreasing value, children. Pink color, this is the decreases. So that is vapor pressure of the solution decreases, negative deviation. Clear? So same thing. So we have what happens? Vapor pressure increases. Vapor pressure increase agrena positive deviation agumbodhu boiling point decrease aidum, the liquid start to boil very fastly. I mean, they will go to the vapor pressure very high, right? So BP of the solution is lesser than the BP of this is also a very important point, children. I hope you can see this one, right? Boiling point of the solution is lesser than the boiling point of the A and B, because avangalukku vapor state easier போக முடியும். So vapor state easier போறேனா boiling point is less. Now boiling point of the solution is more than the boiling point of the A and B. Clear everyone? Clear? Just have a note of this. So positive deviation காமிக்கிறது water and ethanol, chloroform and water, ethanol and CCl4, methanol and chloroform. இங்க negative deviation chloroform and acetone, usually chloroform தான் negative deviation, I mean low vapor pressure காமிக்குது. H2 and HNO3, H2 and HCl, acetic acid and pyridine, phenol and aniline, all these are showing the negative deviation. You have to study the examples also. These are very important. Just make a note of it. இது வந்து வேண்டாம், நீங்க அது மட்டும் படிச்சா போதும், இந்த டெப்த்ல அவங்க கேட்க மாட்டாங்க. Now comes the azeotropic mixtures. Azeotropic mixtures சொல்றது it's a very important another point. அந்த ஒரு டீவியேஷன் சொன்னோம்ல, ரால்ஸ் லால இருக்கிற ஐடியல் சொல்யூஷன்ல இருக்கிற டீவியேஷன், அந்த டீவியேஷன் டு தி எக்ஸ்ட்ரீமா போயிட்டு அந்த ஒரு மிக்சர் வந்து we cannot separate it at any medium, any point. அதுதான் ஒரு azeotropic mixtures சொல்றது. Liquid mixtures, say listen carefully, liquid mixtures or very large deviation from the ideality leads to the special cases of the mixture which is called as the azeotropic mixture or constant boiling mixture. ரெண்டு மிக்சருமே ஒரே பாயிண்ட்ல பாயிலிங் பாயிண்ட் இருக்கும்போது இல்ல ஒரே பாயிண்ட்ல அதோட பெகுலாரிட்டிஸ் இருக்கும்போது நமக்கு அதை செப்பரேட் பண்ண முடியாது. ஸோ அந்த டீவியேஷன் வந்து எக்ஸ்ட்ரீம் லெவலில் போயிட்டு they will be creating the azeotropic mixtures. Liquid mixture which boil at a constant temperature and can be distilled without any change in the composition. A boiling liquid mixture as azeotropic composition produce the vapors of exactly the same composition as that of the liquid. So they will be creating, we cannot separate it at any medium. So we cannot see composition of the liquid mixtures at which the distillation cannot be separated the liquid. ரெண்டு liquids two liquids சேர்ந்து ஒரு compound ஒரு mixture இருக்கும்போது அந்த two liquids ஓட separate பண்றதுக்கு distillation யூஸ் பண்ணா we cannot use the distillation, okay, and that is particularly called as the azeotropic liquids. Clear? இது வந்து azeotropic இல்ல, they are telling like liquid mixtures which boils at a constant temperature and we can distill it. distillation பண்ண முடியும். ஆனா என்ன ஆயிடும்னா ஒரு பாயிண்ட்க்கு அப்புறம் we cannot distillate it. They will be changing into the azeotropic mixtures, which is we cannot distillate or we cannot separate them. So there is a maximum boiling mixture. Azeotropes are the minimum boiling azeotropes are there. There are two types. So azeotropes, when in a mixture, composition of the liquid and the vapor phase becomes equal. So we cannot, like we can say that liquid இருக்கும் and the vapor phase equal இருக்கும். நமக்கு அதங்கள என்ன பண்ண மாட்டோம். We cannot separation, no separation by distillation. Separation by distillation is not possible for the azeotropes. Clear everyone? Clear? Now minimum boiling azeotropes and maximum boiling azeotropes and minimum boiling azeotropes. Non-ideal solution shows large positive deviation. You know that showing large positive deviation, whichever is the non-ideal solution which is having large positive deviation, which is from the Raoult's law, they will be forming minimum boiling azeotropes, that they will be boiling at the lower temperature or the temperature lower than the boiling point. அந்த காம்பவுண்ட்ல இருக்கிற A and B இருக்கிறத விட கம்மியா பாயிலிங் பாயிண்ட்ஸ் ஏக்கும் பிக்கும் 30-50 இருந்தனா அதை விட கம்மியா இருக்கிற பாயிலிங் பாயிண்ட்ல they will be boiling, and that is actually minimum boiling azeotropes. Are you getting my point, children? Everyone? Now that is actually the that is actually the minimum boiling. This should be the minimum. This should be negative deviation the maximum varum. Idu inga thappa koduthirukanga. This is actually the maximum. Okay, here the maximum da varum. Okay, and non-ideal solution showing large negative deviation from the Raoult's law. Now large negative deviation vandadala negative values vandadala which was the vapor pressure was lesser. That temperature, what happens means, you know that the boiling point will be very high. Correct? அந்த காம்போனன்ட் ஏயும் பியும் கம்பேர் பண்ணும்போது பாயிலிங் பாயிண்ட் ஹையா இருக்கும்போது நெகட்டிவ் டிவியேஷன் வந்துருச்சு. அந்த azeotropes தான் மேக்ஸிமம் பாயிலிங் azeotropes சொல்றது. Clear everyone? Clear? Now the ethanol and water mixed containing 95% by the volume of the ethanol is an example for the minimum boiling. A mixture of HNO3 and H2O containing 68% of HNO3 and 32% of water by mass. This is an example for the maximum boiling. And another example also chloroform and methanol mixture and formic acid and the water mixture. These are the examples. Clear? And they are giving the values also. These are not that much important, but you have to know about these things. See, nothing is there. When the boiling point is less now, you know that when the positive deviation happens, boiling point was minimum boiling point was the, so the lower the boiling point of A and B means it's minimum boiling azeotropes. If it is greater the boiling point means it's maximum boiling azeotropes. That's it, nothing else. Okay, now we are going to the இப்போதா கதையே ஆரம்பம், இனிமேல் தான் ஆரம்பமே. So now we are going to look about the colligative property. Colligative properties என்னன்னா, first of all colligative propertiesக்கு முன்னாடி Van Hoff factor சொல்லிட்டு ஒன்று இருக்குது, அதை பற்றி தான் நம்ம படிக்க போகிறோம். அதோட அந்த வேறு equations எல்லாம் not that much important. Okay, so colligative properties சொல்றது properties of the solution that are dependent only the total number of the solute particles தான் அவங்க டிபெண்ட் பண்றாங்க, not in the solvent. Colligative property சொல்றது ஒரு சொல்யூஷன்ல இருக்கிற property of a solution where the particular property is depending upon the solute particle, not the solvent one. Okay, they are not depend on the nature of the particle, that is shape, size, charge, etc. அவங்க அந்த பார்ட்டிகளோட நேச்சர் எப்படின்னு இல்லை. Okay, they are not dependent upon the nature of the particles, shape or size or charge, etc. Colligative properties are relative lowering of the vapor pressure, elevation in the boiling point, depression in the freezing point, and osmotic pressure. What are the four colligative property? The depression in the vapor pressure, relative lowering of the vapor pressure, depression in the freezing point, elevation in the boiling point, and osmotic pressures are the four colligative properties. Now you have to know about this Van Hoff factors or Van Hoff factor or this abnormal colligative property in order to get into the, that is I. Colligative property பத்தி நம்ம அதோட derivation எல்லாம் பார்க்கறதுக்கு முன்னாடி நீங்க இது தெரிஞ்சுக்கணும். This is very important. Okay, listen carefully. If a solute, ஒரு solute வந்து dissociate பண்ணிட்டாங்க, NaCl, ஒரு solute NaCl ஒரு solute இருந்துக்கோங்க, Na plus Cl minus they dissociated. Okay, and அவங்களோட experiment, then the experimental observed and the actual value of the colligative property will be different from their theoretical value. நம்ம தியரட்டிக்கலாக ஒன்று ப்ரிடிக்ட் பண்ணிடுவாங்க, அந்த சொல்யூட் டிசோசியேட்டோ இல்லை அசோசியேட்டோ பண்ணும்போது அவங்களோட அந்த ப்ராக்டிக்கலாக கிடைச்ச அந்த வேல்யூ வந்து டிஃப்ரெண்டாக இருக்கும். ஃபார் எலக்ட்ரோலைட்டிக் சொல்யூட்ஸ் the number of the particles would be different from the number of the particle actually added due to the dissociation. ஸோ நம்ம அந்த எவ்வளோ நம்பர் ஆஃப் பார்ட்டிகல்ஸ் அந்த பர்டிகுலர் electrolyte means electrolytic solutes means which will be having charge separation. So electrolytic solutes the number of particles would be different from the number of particles actually added to the dissociation or association. Association நம்ம ஆட் பண்ணும்போது இருந்த அந்த பார்ட்டிகல்ஸோட number of particlesம் கிடைச்ச number of particles will be different. That's why we are called as abnormal colligative property. NaCl plus H2O gives Na plus plus Cl minus. See, this is different, right? See, on adding 1 moles of NaCl in excess, 1 mole of NaCl in excess and excess in water, it gives 1 mole of Na plus and 1 mole of Cl minus, which means 2 moles of solute we are getting. So what we are theoretically we are getting and experimentally we are getting is different. Abnormality in a colligative property can be calculated in the terms of Van Hoff factor. Are you getting my point? இப்போ ஒரு NaCl எடுத்து நம்ம என்ன ஒரு NaCl excess amount of H2O dissolve பண்ணிட்டேன்னா we expected like same one will be getting in the product, but 1 mole of Na and 1 mole of Cl minus ions are getting. So that is something we didn't expect it, right? So that is something called as the abnormal colligative property. Now this is Van Hoff's factor, which is actually required while you are doing all the particular colligative properties questions. Now you will be having a lot of questions related to osmotic pressure, relative lowering of vapor pressure, everything. You have to add this I factor, and there is a lot of time where the I will be equal to a lot of things which we will be writing in the cheat sheet. Okay, in the last end of the session, I want to remember it. Okay. So Van Hoff's factor I is equal to observed colligative property, whichever is observed and whichever is calculated. Whichever we observed and whichever is calculated is actually called as the I. We can also say that it is the moles of the solute. It is the moles of the solute in the solution which is after the dissociation, because it is observed one now. After the dissociation, what we are observing. So it is the number of moles of the solute after the dissociation divided by number of moles of the solute before the dissociation. See, number of moles of the solute number of moles of the solute particles in the solution after the dissociation. After the dissociation only we will be getting the observed one, right? Divided by moles of the solute before means calculated one. Okay, this will be going to happen, this is the one we will be calculating it. So that is the I. So the actual extent of dissociation and association can be expressed in the correction factor, which is known as the Van Hoff's factor. So that's why we are just doing some correction on that, and for representing that we are giving the I value while doing the colligative property. So now Van Hoff's factor I, like when the dissociation happens means I will be greater than 1. Okay, if there is no dissociation or association, for example urea, all those compounds are there, neutral ones, they don't have any dissociation or dissociation. Urea, glucose and all, they will be having just I is equal to 1. Usually they will be giving the examples like this, no dissociation and association. If there is an association means it will be less than 1. So I dissociation for the electrolyte. So you know that Ax plus By is an electrolyte. It will be dissociated as XaY plus YbX minus. You know how to dissociation happens and all, right? So at the temperature 0, C Walzer concentration, initial concentration. At that particular initial concentration there were no product. 0, 0. Particular temperature or particular time passes, what happens? From this we are telling like we are giving that particular alpha is given. Okay, so we can say that this particular alpha is given and that alpha will be added to the, right? So C alpha, that in order to denote that X and Y, the moles we are giving here. Okay, so net concentration will be, we can say that C into, we are giving this as a 1. Okay, that's why 1 minus alpha. So 1 minus alpha instead of the C minus C alpha. C minus C alpha into X C alpha by Y C alpha. These are the coefficients. Okay, so C into C minus C alpha means we can take the C outside and C X plus Y minus 1 from this one. Okay, see, we are taking all this alphas outside, x plus y minus 1, x plus y minus 1, and from this we will be getting c into 1 plus n minus 1 into alpha. This is only required for you. No, the derivations and all is not required. This is only required for you. Okay, so this was the equation. How this come is, the certain c was there and this was the molecule. From the molecules, alpha gons means c into c1 minus alpha. That alpha will be added in the product. So x has c alpha and y c alpha. This you will be studying in the equilibrium also, right? From there we will be getting the net concentration c into 1 plus n minus 1 into alpha. This is only required for you. This derivation is not required. This is only required for you. Okay. I for dissociation of the electrolyte, we got it. So one second children. Dissociation of. So alpha by c, alpha is decreasations. Okay, so one more thing here, I have to add one NaCl. NaCl means that is a dissociation electrolyte, Na plus and Cl minus, right? So I will be what? It will be completely dissociated, which is 100% ionized or 100% dissociated, means completely they have splitted Na plus and Cl minus. So Na plus and Cl minus to one another. So I will be 2. In the other hand, if you have this BaCl2 or something, BaCl2 means they dissociated into Ba2 plus 2Cl minus. Am I correct? So 1 plus 2, 3. So I will be 3. If this 100% ionized and dissociation, I am telling you, it's 100% means you can go it like this. Clear? 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 Or you can go this, if it is not the 100% or something, you have to do this value. I hope this is clear for you guys. One second, children. Okay, for association, these values are not required. C, C minus, they are giving in the beta, and you just require this one. One second. This one is required. Okay, final equation, this one is required. And for the dimerization of the CH3COH is 100%, means it will be 0.0.15. Dimerization of C6H5COH means 0.5. Now, colligative properties, I told you, relative lowering pressure, relative lowering of the vapor pressure, relative elevation of the boiling point, depression in the freezing point, and the osmotic pressure. So I, you got to know that I is equal to, when there is no dissociation or association, I is equal to 1. If there is a dissociation or association, what is the number of N? Correct? Right or wrong? Yes, na? Yes. For example, CH3COOH is 10% ionized. Okay, so CH3COOH is 10% ionized, and CH3COOH is a weak electrolyte. You know that. So always remember, weak electrolyte means, what is the formula we have to follow, children? I is equal to 1 plus n minus 1 into alpha. Now tell me how you will be writing. See, for dissociation you know that I will be greater than 1 also. So how you will be writing this particular one? 1 second. This is only the equation. Huh? Yes, this is only the equation. So tell me, the equation will be I is equal to 1 plus n minus 1 into alpha. Am I correct, children? 1 plus n minus 1 into alpha. So you got to know that alpha is equal to 10%, which means 10 by 100. Am I correct, my dear students? 10 by 100, right? So 10 by 100 means 0.1 is the alpha, and when this particular CH3COH is dissociating, means it will be dissociated as CH3COO minus plus H plus. So from this n is equal to 2. Am I correct, my dear students? Right or wrong? N is equal to 2. So I is equal to 1 plus n minus 1 into alpha, 1 plus 2 minus 1 into 0.1. Am I correct, my dear students? Right or wrong? So you can say that 1 plus 0.1, right? 1 plus 0.1 will be 1.1. So this is an example. So 1 plus n minus 1 minus 1 into alpha. How you will write it when it is an weak electrolyte? Now, okay. This is much better, children. You go for, so when it is a weak electrolytes means we can say that, so when it is a weak electrolytes, this is much more easier than following that particular slide. It will make you confused, okay? When it is weak electrolyte, For example, weak electrolytes means what are the weak electrolytes, children? Tell me. Fast. Weak base will be there and even weak acids also. Right? They are weak electrolytes, right? Weak acids and weak base, right? Now, I'll give you another example. I will add one more slide here. Okay? Do this also. For example, H2O. H2SO4 is 90% ionized. Now you may think that, ma'am, H2SO4 is not a weak electrolyte, it's a strong electrolyte. It is, how can it's 90%, no, 95%, 95%, how it is 95% ionized or dissociated? Children, they have the ability to dissociate it into 100%, but they are not doing that. They don't want it. 95% is more than enough for them. So they are given in the question itself is the dissociation is alpha is not 100, it's just 95% only. So the same equation, I is equal to 1 plus n minus 1 into alpha, correct? This is the same question now. Is this the same question which we have done? If I'm not wrong. If the dissociation is not 100%, I'm telling you, okay? I is equal to 1 plus n minus 1 into alpha, 1 plus n is equal to H2SO4 now. H2SO4 when they dissociated, what will be the value, children? 2H plus SO4 2 minus, which means n is equal to 3. So n3 minus 1 into alpha, which is alpha is equal to 95%, my dear students, listen carefully. So 95% we cannot calculate, 95 by 100, which will be equal to 0.95. Now 1 plus 0.95, right? 1 plus 2 into 0.95 will be the value of I here, correct? Value of I which will be greater than 1 for the dissociation, right? 2 will be, one second. 2 into 0.9, right? Which will be equal to 1 plus 1.90, correct? 2.90, right? 2.9, that is enough. Okay, so that is actually the 1 plus 1 minus, so that is actually greater than the 1, correct? It's actually greater, it is greater than the 1. Now, I want you guys to note down one more thing. I'll give you, for example, so weak electrolytes we have done. Weak electrolytes means the ionization is not completely gone, right? The ionization is not completing. For the strong electrolyte, so ionization, see, I'm not telling that H2SO4 is a weak electrolyte or strong electrolyte. Their ionization is not completely done, so we have to do for that equation only. For the strong electrolyte, what happens means, for strong electrolyte means they are 100%. Am I correct? Solute which is dissolved in 100% is called as a strong electrolyte, right? For example, so we got to know that, one second. Alpha is equal to 100%. Alpha value will be 100%. So alpha percentage is 100%. Alpha will be 1. So I is equal to 1 plus n minus 1 into alpha, which is 1 plus n minus 1 into 1. N will be, so we can say that I is equal to 1 plus n minus 1. So I is equal to n. Are you getting my point, children? I is equal to n for the I is equal to n for the particular strong electrolyte in which the 100% is doing. Alpha percentage or ionization or electrolyte, strong electrolyte, they are undergoing the 100% of this dissociation or association. Are you getting my point, children? Everyone? Okay, so n is basically number of ions, right? N is basically, for example, HCl they are giving, HNO3 they are giving, H2SO4 they are giving. These all are strong electrolyte, and they are telling alpha is equal to that 100% means I is equal to n, means n is the how much ions they are forming, right? So H2SO4 means 2H plus SO4 2 minus 3. I will be 3. Are you getting my point, children? Are you getting my point? This is very important. Why means when you are doing the questions now, they will ask you. That's why. So for weak electrolytes, for strong electrolytes, we do the equation, but we got an equation that like I is equal to N. For the strong electrolytes, if 100% dissociation is happening. But even though if the electrolytes is like they are strong only, but the dissociation is not 100%, we have to do the equation and we have to calculate the value of I. Then we have to do it in the equation, I mean in the particular question, and we have to do it. Are you getting my point, children? Are you getting my point? Now, same thing happened to this particular strong acid on strong base, everything. For example, NaOH when we are getting means Na plus plus OH minus. So, we will be getting I is equal to 2 because N is equal to 2 there, right? Are you getting my point, children? Everyone? Everyone? See, if I having the strong electrolyte like HCl, where I will write here, okay. HCl or NaOH and all, what happens? HCl, H plus Cl minus, am I correct? So the Ni will be equal to 2. Why I equal to 2? Because N1 plus 1 is equal to 2. And NaOH means Na plus OH minus. Here also I is equal to 2. Are you getting my point, everyone? Clear? Clear? K2SO4 means it will be 2K plus SO4 2 minus. So the N will be 3. So that is all about the strong electrolyte in order to find the I. This method is much more easier. You will get confused in that. Now comes the non-electrolytes. I will give you an heading. Non-electrolytes. Non-electrolytes means what is the meaning of non-electrolytes? My dear students, tell me what is the meaning of the non-electrolytes. They are not ionized. We cannot do the ionization, or they are not ionized. Urea, this particular urea is an example for the non-electrolyte. Urea, sucrose, glucose, all this comes under the category of the non-electrolytes. So the non-electrolytes means this alpha will be equal to the 0, right? So I is equal to 1 plus N minus 1 into alpha. Alpha is equal to 0 because there is no dissociation or ionization is not happening. So 1 plus N minus 1 into 0. So I is equal to 0. I is equal to 1. I equal to 1 for, usually they will give you the non-electrolytes only, children, don't worry about it. I is equal to 1. I equal to 1, and you can also write here like urea, glucose, all this will be having the non-electrolytes. Okay, I equal to 1. Simply you can do. You don't want to do any calculation also there, right? The value of the vapor pressure, or I mean relative lowering of the vapor pressure or depression in freezing point, everything will be same. You just want to do the calculation only. You don't want to give the value of I. So usually they will be giving you that only, but in some cases they can give this also. Okay, strong NaOH, K2SO4, HCl, all those things, MgSO4, all those things you have to calculate the I is equal to N. Okay, we will do some problems, then you will get to know that. In the live session we will do some problems, okay? Okay, so this is all about the Mansour factor for strong electrolytes, for weak electrolytes, and for non-electrolyte. Now we have to go for the relative lowering of the vapor pressure. Relative lowering of the vapor pressure is nothing, children. See, I told you there is a solution. It's been 50 minutes. I have been continuously teaching you guys. So I told you there is a solution. I mean, there is a beaker and that solution is there. Like it's a pure solution, like just A only. Okay, that is a volatile one. Volatile one means, one second, children. Yeah, that is actually the volatile one. Volatile one means which will be going to the vapor state, right? So A is there. Now I'm adding a solute. Okay, that's what a colligative property na. In the first, you know that I told you to note down a point here, right? You remember I told you to note down a point here na. Here in the starting of the session, liquid plus liquid is equal to Henry law. Liquid plus solid is equal to this particular Raoult's law. And no, liquid plus liquid is equal to liquid plus gas is equal to Henry law. Liquid plus liquid is equal to Raoult's law. Liquid plus solid is equal to colligative property. There we are coming. To that we are coming, okay? So I have a solution, I have a beaker and I am having a solution and I added the solution which is actually a volatile one. Volatile one means which will be going to the vapor state. Clear? இப்போ புரியுதா? இது வரைக்கும் புரிஞ்சுதா? ஓகே. நவ் இப்போ என்ன ஆகுறேன்னா நான் அதுக்கு வந்து ஒரு I'm adding a non-volatile solute into that. Non-volatile means what is happening? Non-volatile means what will be happening, children? So this is my solution. This was my solution A. Okay. So they will be having these vapors of this A. Okay. So vapor pressure was there. Now what happens means to this particular liquid A, I had added some solute, children, which is non-volatile. They not undergo the volatile state. They are just staying there. So what happens? They will be having a vapor pressure here. When I added a non-volatile solute to the solvent, what happened to the vapor pressure? See, vapor pressure, see this particular white color substance, white color liquids are going to the vapor pressure. But this blue color, they won't be going. Right? This A plus B, this B is the solute, which is non-volatile. So what happens? They won't be undergoing to the vapor state. They will be producing a hindrance also for the other molecules, right? அவங்க வந்து தடுத்துருவாங்க. So vapor pressure வந்து என்ன ஆயிடும்? Increase ஆயிடுமா, low ஆயிடுமா? There will be lowering of the vapor pressure. Am I correct? The pressure will be vapor pressure because vapor state க்கு போறதே கஷ்டமா இருக்கும். அப்ப vapor pressure க்கு என்ன ஆயிடும்? There will be a lowering of the vapor pressure. Vapor pressure lowered. Am I correct? Or else we can say it like this. Okay, we can also say it like this in such a way that when a non-volatile one second children. When a non-volatile solute is added to the solvent, there will be a decrease in the vapor pressure. So என்ன ஆகுறேன்னா pure vapor pressure இருந்ததுல, இப்போ A இருந்த அந்த solventல pure vapor pressureல, just a second children. Okay, A இருந்த அந்த எங்க நம்ம சொல்லிருந்தோம், திடீர்னு இதுல எனக்கு தெரியாம போச்சதா. ஓகே, எங்க சொல்லிட்டு இருந்தோம் ஸ்டூடெண்ட்? ஓகே, ஸோ நம்ம வந்து ஒரு பீக்கரில் வந்து நம்ம வந்து அந்த ஒரு பியூர் சால்வெண்ட் ஏ போட்டுருதான், அதில் வந்து ஒரு நான் வாலடைல் சொல்யூட் போடும்போது என்ன ஆகுற, அந்த பியூரான விஷயத்தோட வேப்பர் ப்ரெஷர் கம்மியாயிடும் சொல்யூஷனுக்கு. அப்போது சி லிசன் கேர்ஃபுல்லி, ஐ ஜஸ்ட் வாண்ட் டு ஆட் ஒன் மோர் பாயிண்ட் ஹியர். ஸோ as I told you, just a second, something is happening here. Okay, as I told you, this is the A and this was the pressure, which was the pure pressure P naught A. Am I correct? Now I had added some solute which is non-volatile solute, right? Now this became a solution, correct? It becomes a solution. So this particular solution is a mixture of the both volatile and volatile solvent and non-volatile solute. Are you getting my point, children? This is a solution, right? Solution means you will be having A also, you will be having B also. Am I correct? So what happens to this particular pressure, vapor pressure or the pressure of the solution decreases, correct? Pressure of the S means solution, P naught A means just that pure one, or P naught, we can say that P naught. This is PS. It decreases when we add a non-volatile solute into the solvent, which is a pure volatile one. The vapor pressure is decreases because they are not supporting to the solvent to go to the vapor state. So the vapor pressure decreases, and that is actually called as the relative lowering of the vapor pressure, which is a colligative property. See? Oh my god. This one. See, vapor pressure of the solution containing a non-volatile solute is always found to be less than the vapor pressure of the pure solvent. So always remember, pure solvent will be having more vapor pressure when compared to the solution. Clear? So this is what P1, P is equal to P2. Here it was okay. When we add, here this is the scenario. Pure one, P1, pure solvent A, pure solvent B, they will be having same vapor pressure. But when we add a solute which is a non-volatile one, what happens? This is the solute which is having a non-volatile one. This is the pure one. So pure one will be having more one. Pure solvent A. That will be greater than the solution. Clear everyone? That is PS means they will be having the, listen, this is very important, non-volatile solute and plus solvent. This is just have pure solvent. Clear? This we have discussed. So reason for the relative lowering, some of the solute molecules will occupy the surface area of the solution. So what happens? They cannot go to the vapor state. So tendency of the solvent particles to go to the vapor phase will be slightly decreases. So that's why the vapor pressure decreases. Hence P naught S is greater than PS, where the P naught is the vapor pressure of the pure solvent, PS is the vapor pressure of the solution. Are you getting my point, children? Are you getting my point? See what happens, solvent, they will be fastly, they go to the vapor state and they will be going the vapor pressure will be exerting. But here the solvent, I'm telling you, solution what happens? This is solvent, children. Solution what happens? They will be having a konja oru tayakama irukku ennada nu irukum. Puriyudha? Okay. So this equation, one second. Here I will tell this equation as in separate slide. Relative lowering of the vapor pressure is a colligative property, where the lowering in the vapor pressure is not. Relative lowering is different. Lowering is delta. Relative lowering means we are related to something, they are lowering. I'll tell you what it is exactly. Listen carefully, my dear students. So I just want you to listen to this particular ones. One second. Okay, I will just tell you one more time this. Listen carefully. I will discuss it with you. You know that, see, this is actually according to the Rawls law. You know that total pressure of this one is equal to pure one into chi of the solvent. That is mole fraction of the solvent. If you don't know, please do write down this also. This is also the abbreviation for the ideal solution of the Rawls law. Okay. From there, we can understand that PS by P naught is equal to chi of solvent, right? We can just take it into the denominator, and we can just take this particular one into denominator, and we can write it PS by P naught is equal to chi solvent. Correct, chi of the solvent. Did I want to write it one more time, children? Okay. Not needed. So PS by P naught is equal to chi of solvent, which is the first equation, and we do know that chi of solvent is equal to chi of solvent plus chi of solute is equal to, what is the value? 1, right? From there we can say that 1 minus chi of solute is equal to chi of solvent. So PS by P naught is equal to chi of solvent means 1 minus chi of solute, right? From there we are taking the chi solute only, and 1 minus PS by P naught. This PS by P naught, we can write it here. It will be going here, P naught minus PS by P naught. This is actually the relative lowering of the vapor pressure. Am I correct? With respect to the solvent, PS, P naught minus PS. This is the delta P, children. Delta P by P naught, which is the relative lowering of the vapor pressure. This is actually a colligative property, but just delta P is not a colligative property. Are you getting my point? when related to the P naught, which is the vapor pressure of the pure solvent, it is a colligative property. But just P naught minus PS is not a colligative property. Clear everyone? Clear? Paka? Good to go? Okay. Now, so P naught by PS is equal to chi of solute. So this equation is there now. This equation, that is PS by P naught, and this equation, which is this equation. This one. One second. This equation we have to multiply. So what we will be doing now? Delta P by P naught by PS by P naught. PS by P naught is the first one, we have already get it from the first equation. Okay, so by chi of solute by solvent. I hope this is clear. From this we are going to here. Okay, P naught minus PS is equal to delta P by P naught, and from here we are taking this particular equation and we are just making them to do it. Okay, so we can cut off this P naught and delta P by PS is equal to chi of solute by solvent. Are you getting my point, children? Delta P by PS is equal to chi of solute by solvent. Now, from this P naught minus PS by PS is equal to, P naught minus PS by PS, delta P now. Delta P by PS is equal to chi of solute divided by chi of solvent, which we already given and get in the next equation, previous equation. From that, chi of the solute is equal to N2 by N1 plus N2. Now you remember why I give you 2 and 1. Okay, divided by N1 by N1 plus N2. This is what we have given. Okay, there, see N2 by N1, we can cut short this particular one and we can write it as N2 by N1. P naught minus PS by PS is equal to N2 by N1, where we can say that we have to give this particular Van-House factor also. Okay, then you got the equation. This is your equation for the while doing the sums and all. This is very important, and also this equation also is very important, children. There is another equation, the equation which is denoting the solute and solvent is there, no? This is also important equation, and even this one also. This is the solute. PS by P naught is the chi of solvent, that is one equation. P naught minus PS by PS is equal to the chi of solute. P naught is equal to chi of solute, and whichever is this equation. These are the three important equations of the vapor pressure. Are you getting my point? Now from this, there is another important equation also which is relating to the molality. P naught, I will write this here better. Listen, we got the equation as P naught by PS. We got the equation as P naught minus PS by PS is equal to N2 by N1, which is I. Am I correct, children? Am I correct, right or wrong? Yes, this is the equation, we got it. So, you know the molality is equal to molality, liter. So, which will be the weight, of the solvent will be the, so number of moles of the solute divided by the weight of the solvent or mass of the solvent. Not weight, actually mass of the solvent, which is in the liter means into 1000, right? So, we can take this particular both here. So, number of moles of solute divided by the mass of the solvent is equal to molality into 1000. Molality divided by 1000. Am I correct, children? Are you getting my point, children? I am just taking that in this side, so molality by 1000, right? Did I make any mistake here? Just a second, children. Give me a second. Correct only, molality by 1000. Moles of the solvent, correct only. Now listen carefully. Number of moles of solute divided by the weight of the solvent. Okay, number of moles of the solute divided by the weight of the solvent divided by the molar mass of the solvent. See, children, what I have done is N1. What is the value of the N1? N1 is equal to N1 is the mass of the solvent, or we can say that weight of the solvent, which is W1 divided by the molar mass, Wm1, correct? For that, I gave this value, weight of the solvent or mass of the solvent divided by molar mass of the solvent. So, this N2 by this particular weight of the solvent. Now, listen, this is very important. N2 by this weight of the solvent, I can give the value by molality by 1000. Molality by 1000, and this will be coming in the upside down, so mass of the solvent. Are you getting my point? In short, P naught minus Ps by Ps is equal to I into molality into mass of the solvent. Can I tell you one more time? Listen carefully. You got this equation. Okay, I will write it one more time. That's much better. What was the equation? P naught minus Ps divided by Ps is equal to, write along with me, okay, N2 divided by N1. Okay, okay, fine. Okay, now molality is equal to N2 divided by 1000. From this I'm taking this side. So N2 by W1 is equal to molality by 1000. Okay, now P naught minus Ps by Ps is equal to N2 divided by N1. N1 na? Correct na? N1 சொல்றது N1 is equal to number of moles of solvent is equal to mass of the solvent divided by the molar mass of the solvent, or weight of the solvent divided by the molar mass of the solvent. So we can say that M1 divided by, one second, W1. W1 divided by M1. Am I correct? Now, this whole one, I'm giving this particular value. Same na? Both are same na? So, molality into 1000, the denominator will be going to the numerator, and P naught minus Ps by Ps is equal to molality by 1000 into M1. Are you getting my point, children? Are you getting my point? Clear, everyone? Clear? So this is how. This, you have to get to know that this is the molar mass of the solvent. Usually water will be there. This is the molality. They will be giving you the molality liti, not liter, not riti. Okay? Clear, everyone? This is clear? So this is another very important equation for this particular, for your vapor pressure. Okay? Note பண்ணிக்கோங்க. Okay, in the equations எல்லாமே அது வரது எப்படின்னு ரொம்ப இம்பார்ட்டன்ட் இல்லை, பட் யூ ஹாவ் டு நோ தட் லைக் எதெல்லாம் எப்படியெல்லாம் வந்துடுச்சுன்னு இருக்கிறது தெரியணும். ஓகே, ஸோ ரோல்ஸ் law for the non-volatile, the vapor pressure is equal to the temperature multiplied by the this is what we have discussed. All those things we have discussed. I molality into 1000. We got the equation. Okay. Now, elevation and the boiling point. Children, this is another colligative property. So, I told you when a non-volatile solute is added, that is a solid or liquid solute is added to the volatile liquid, you got to know that the vapor pressure will be decreases. When the vapor pressure decreases means they are going on, அவங்க வந்து அந்த vapor pressure decrease பண்றாங்கன்னா அதோட pressure கம்மி ஆகுது, அவங்க vapor stateல போக மாட்டேங்குது. So, vapor stateல போக மாட்டேங்குது சொல்லும்போது அவங்களோட boiling point increase ஆயிருக்கா decrease ஆயிருக்கா? See, அவங்க vapor stateல போறேன்னா அவங்களோட பாயிலிங் பாயிண்ட் கம்மியா இருக்கும் அந்த 50 டிகிரி செல்சியஸ் இல்ல 25 டிகிரி செல்சியஸ்ல தான் அவங்க பாயிலிங் பாயிண்ட்க்கு போறாங்க. ஐ மீன் பாயிலிங் பாயிண்ட் ஆகுறேன்னா வேப்பர் ஃபேஸ்ல போயிருப்பாங்க. ஆனா இந்த வேப்பர் ஃபேஸ்ல போக மாட்டேங்குது, அவங்க வந்து அது கம்மியா இருக்கு வேப்பர் பிரஷர். ஸோ ஆப்வியஸ்லி அவங்களோட பாயிலிங் பாயிண்ட் என்ன இருக்கணும்? இன்க்ரீஸா இருக்கணும். ஐ ரிப்பீட் லிசன் கேர்ஃபுல்லி. சரி, ஒரு நான் volatile சொல்யூட் நம்ம ஆட் பண்ணிட்டு சப்ஸ்டன்ஸுக்கு நம்ம ஆட் பண்ணிட்டோம் நான் volatile சொல்யூட். ஓகே, volatile liquidக்கு ஆட் பண்ணிட்டோம். ஸோ நான் volatile solute நம்ம ஆட் பண்ணிட்டோம். நான் volatile solute நம்ம ஆட் பண்ணும்போது லிசன் கேர்ஃபுல்லி, திஸ் இஸ் வெரி இம்பார்ட்டன்ட். நம்ம நான் volatile solute நம்ம ஆட் பண்ணிட்டோம், அவங்களோட அந்த வேப்பர் ப்ரெஷர் சொல்றது கம்மியா இருக்கு. when we add a non volatile solute, it is vapor pressure is decreases. Vapor pressure decreases means அவங்க வேப்பர் ஸ்டேட்லக்கே போக மாட்டேங்குது because of a non volatile solute. non volatile னா அவங்க non volatile means they are not ready to go to the vapor state. அப்ப non volatile solute இருக்கு, solvent இருக்கு. solvent வந்து வேப்பர் ஸ்டேட்ல இருக்கிற போக முடியும், volatile ஆன விஷயம். ஸோ ஆனால் அவங்களுக்கு போகிறதுக்கு தடுக்கிறாங்க. ஆமாம் தானே? அதனால தான் வேப்பர் ப்ரெஷர் கம்மியாக இருக்குது. ஸோ வேப்பர் ப்ரெஷர் கம்மியாக இருக்குன்னா வேப்பர் ஸ்டேட்டுக்கு போகிறதுக்கு டிஃபிகல்ட்டாக இருக்குது. வேப்பர் ஸ்டேட்டுக்கு போகிறதுக்கு டிஃபிகல்ட் ஆகுறாங்கன்னா அவங்களோட பாயிலிங் பாயிண்ட் இன்க்ரீஸ் ஆயிருக்குமா டிக்ரீஸ் ஆயிருக்குமா? யோசிச்சுப்பா சொல்லுங்கள். பாயிலிங் பாயிண்ட் இன்க்ரீஸ் ஆயிருக்கணும் மேம். பாயிலிங் பாயிண்ட் டிக்ரீஸ் ஆகிட்டேன்னா ஈஸியாக வேப்பர் ஸ்டேட்டுக்கு போயிடுவால. லிக்விட் 50 டிகிரி செல்சியஸில் ஹீட் ஆகுறேன்னா ஈஸியாக பாயிலிங் பாயிண்ட் ஆகிடும். ஈஸியாக அவங்களுக்கு 50 டிகிரி செல்சியஸில் அவங்க போயிடுவாங்க. இது வந்து அந்த லிக்விட் பாயில் ஆக மாட்டேங்குது. அப்போ வேப்பர் ப்ரெஷர் நிறைய பாயிலிங் பாயிண்ட் நிறைய கொடுத்துருக்கணும். ஸோ when we are adding a non-volatile solute to a volatile solvent, vapor pressure decreases and the boiling point increases. what is happening to the boiling point? It is increasing. So when a non-volatile solute is added into the volatile liquid, when a non-volatile solute is added to the volatile liquid to form a solution, vapor pressure decreases, boiling point increases. Solution need to be heated at higher temperature to boil so that vapor pressure becomes equal to the external pressure. Vapor pressure external pressure increase. See, that is what the boiling point, right? Boiling point சொல்றது vapor pressure external pressure ஒரே I mean அந்த ஒரு பாயிண்ட்ல எத்துறதா boiling take place பண்ணுவோம். அப்போ அதுக்கு வந்து இன்னும் boiling point increase ஆகணும். So atmospheric pressure, solution with the solute, what happens? Lowering the vapor pressure will be lower பண்ணிடுவாங்க. Atmospheric pressure intake பண்ணிடுவாங்க, இன்னும் அதிகமாக ஆகிடும். ஸோ வாட் ஹேப்பன்ஸ், பாயிலிங் பாயிண்ட் நம்ம இன்க்ரீஸ் பண்ணி தான் ஆகணும். Are you getting my point? இது கொஞ்சம் ஸ்கிரிபிளாக இருக்குது, டோன்ட் வரி, ஐ வில் டெல் யூ. ஸோ எலிவேஷன் இந்த பாயிலிங் பாயிண்ட் இஸ் பேசிக்கலி லிசன் டு திஸ் பர்டிகுலர் கிராஃப் ஃபர்ஸ்ட். ஓகே, கிராஃப்லேருந்து இதிலிருந்து ஒரு கொஷின் ஏதோ கேட்டிருக்காங்க, அந்த கொஷின் நான் நோட் பண்ணிவிட்டு ஐ வில் டெல் யூ டூரிங் த லைவ். ஓகே, ஸோ டெம்பரேச்சர் இருக்குது, வேப்பர் ப்ரெஷர் இருக்குது. ஓகே, ஸோ திஸ் இஸ் யுவர் சால்வெண்ட். ஓகே, when the temperature increases, solvent oda vapor pressure இப்படி தான் இருந்தது. ஓகே, ஸோ சொல்யூஷன் ஆகும்போது vapor pressure decrease ஆகிட்டா. ஸோ this was the point of the temperature where the pure solvent was there. Now when the vapor pressure increases, I mean vapor pressure decreases, see the vapor pressure is decreases. Just a second children. When the vapor pressure decreases, what happened to the boiling point? TB means it's because solution. It's of the solution. Okay, what happened to this? It increases. So delta TB is greater than the T naught B. This is very important. There it was different. Elevation, I mean, relative lowering of the vapor pressure different. Inge different. So inge TB is greater than T naught B. Delta TB is equal to TB minus T naught B, because this will be the greater value. So delta TB is equal to this one, and that is directly proportional to the molality. Molality kuda nama eppome you or I, according to this question you have to draw it. Okay, so delta K is equal to your and the proportionality maatradhukku KB, which is actually called as the elevation constant, or it can also called as molar elevation constant solvanga. Illena ebullioscopic constant nu solluvaanga, molar elevation constant, that is more easier, or elevation constant, boiling point elevation constant, that is also easier. So KB vandrum, KB la vandu molality oda and the equation nama W2 by M2 into 1000 by W1. W2 by M2 enga eppadi vandadu, see N2 divided by W1 into 1000 is the molality oda equation. N2 is equal to W2 by M2 dana, mass of the solute divided by the molar mass of the solute. So that one we have discussed and I have given here. Clear? This is very important one. Clear? புரியுதா? அது எப்படி வந்ததுச்சுனா அத இங்க எழுதிருக்காங்க, W2 by M2 into 1000 by W1. Clear? Now KB ஓட ஒரு வேல்யூ சொல்றது RT not B square M into divided by 1000 into delta H of the vaporization. Delta TB is the boiling point of the pure solvent. Delta, I mean T not B, not delta DB, T not B. M is the molar mass of the solvent. Delta H vapor is the molar enthalpy. R is 8.314 joule bar mole Kelvin. Okay. Now their equation units will be kilo Kelvin bar meter or degree Celsius bar meter. Their particular units. I want you to know one more thing. ஓகே, அது அதில் தான் வருது. லைக் ஆர் ஃபேக்ட், அந்த ஆர் கான்ஸ்டன்ட் இருக்குல்ல, அதை பற்றி நான் சொல்கிறேன் ஃப்ரீசிங் பாயிண்ட் முடிச்சதுக்கப்புறம். ஓகே, இஃப் சொல்யூட் கெட் associated or dissociated, delta TP is equal to I into KB into molality. I, of course I will be there. ஓகே, டிசோசியேஷனாக அசோசியேஷனாக வரும்போது ஐ இருக்கும். இப்போ நான் டிசோசியேஷனாக வருதுச்சு அது ஒன்னாக இருக்குது. ஐ மீன் நான் எலக்ட்ரோலைட் இருக்கும்ல, அது இருக்கும்போது ஒன்னாக தான் இருக்கும். ஓகே, ஆர் யூ கெட்டிங் மை பாயிண்ட்? ஸோ KB is the property of the solvent and we can say that the elevation of the boiling point is proportional to the lowering of the vapor pressure. Elevation of the boiling point difference ஆன்னு சொல்கிறது delta TB is directly proportional to delta P. vapor pressure இல்லை, freezing point இல்லை, அதோட difference elevation தான் எதுக்கு proportional இருக்கு delta P க்கு proportional இருக்கு. And Kp for the water, this is also very important one while do the problems and all note பண்ணிக்கோங்க. Ebuloscopic constant for the water is 0.52 kilo Kelvin dot kg mole inverse. Okay children, clear? Now freezing point, இது next one. Freezing point சொல்றது, you know that the temperature at which the particular pressure of the solid, okay, the vapor pressure of the solid become equal to the vapor pressure of the liquid. That அந்த ஒரு பாயிண்ட் தான் நம்ம லிக்விடும் கேஸும் வரும்போது பாயிலிங் பாயிண்டும், சாலிடு லிக்விட் வரும்போது ஃப்ரீசிங் பாயிண்ட் தான் வரும். ஸோ த ப்ரெஷர் ஆஃப் த சாலிட் பிகம்ஸ் ஈக்குவல் டு தி ப்ரெஷர் ஆஃப் த லிக்விட் மீன்ஸ் அந்த ஒரு பாயிண்ட் தான் என்னது நார்மல் ஃப்ரீசிங் பாயிண்ட் சொல்றது, ரைட்? correct, which means vapor pressure of the solid equal ஆகணும், vapor pressure of the liquid equal ஆகணும், pressure ரெண்டுமே equal ஆகணும். எதோடது? சாலிடும் லிக்விடும் கேஸா இருந்தா பாயிலிங் பாயிண்ட் ஆயிடும், சாலிடு லிக்விட் ஆகும்போது தான் ஃப்ரீசிங் பாயிண்ட் வருது. இந்த கிராஃப் ஈஸி தான், don't worry about it, I'll tell you. Now when a non-volatile solute is dissolved in the solvent, the vapor pressure of the solvent decreases. அந்த ஒரு பாயிண்ட்ல இருந்து தான் எல்லாமே வருது, அந்த ஒரு பாயிண்ட் தான் இதுக்கு எல்லாத்துக்குமே ரீசன். ஓகே, ஸோ when non-volatile solute வந்து dissolve பண்ணும்போது என்ன ஆகுற vapor pressure சொல்றது decrease ஆகிடும். Correct? So vapor pressure of a solid and the liquid solvent will become equal at a lower temperature. Vapor pressure கம்மி ஆயிடுச்சு, vapor pressure of the solvent decreases. So அந்த vapor pressure of the solvent solidum இருக்கிற solidum liquid ஆகிறதோடதும் ரெண்டுமே ஒட்டுக்கா வரும்போது அது எப்போ வரும்? யோசிச்சு பாருங்களேன், அந்த freezing point கம்மி ஆகும்போது தானே, which means freezing point of the solution is lower than that of the pure solvent. Pure நம்ம ஒரு solute add பண்ணும்போது அந்த pure solvent விட freezing point கம்மியா இருக்கும், அப்பதான் அந்த freezing நடக்கும். Are you getting my point? I repeat, ஒரு solute ஒரு solventல pure solventல which was a volatile solventல நம்ம ஒரு non-volatile solute add பண்ணும்போது vapor pressure கம்மி ஆயிடும். So vapor pressure of the solidum, vapor pressure of the liquid solventum எப்போ ஒன்னாகும்? pressure கம்மியா, I mean freezing point கம்மி ஆகணும். நார்மலா இருந்த டைமை விட அதோட vapor pressure கம்மி ஆயிடுச்சு, so freezing pointடும் கம்மி ஆகணும். Are you getting my point, student? Are you getting my point? So pure solvent oda vida, which one will be decreased? Just like the lowering the vapor pressure. TF will be greater than, I mean T naught F, not TF children, T naught F will be greater than the TF. T naught F will be greater than the, என்னடா இது? Okay. ஐயோ, T naught F will be greater than the TF because there will be decrease in the freezing point. Are you getting my point? See, this is the T naught F. Okay, this is the temperature and the pressure graph which was in the solid, liquid and the gas. So this was the pure solvent. Okay, during this time this was the T naught F and this was in the solution. So this is almost, this is a TF. So this is having more value. Listen, I'll tell you. இது பாருங்களேன், இதுக்கு தான் நிறைய வேல்யூ வந்திருக்கு T naught F க்கு. இங்க அது வந்து அது வந்து சொல்யூஷன் ஆகிற டைமில் என்னாச்சு, அதோட வேல்யூ கம்மி ஆயிடுச்சு. கிளியர் எவ்ரி ஒன்? பிகாஸ் தே ஹாவ் டு கோ டு தி சாலிட் ஸ்டேட், சாலிட் ஆகணும்ல, ஸோ அதோட வேல்யூ ஃப்ரீசிங் பாயிண்ட் கம்மி ஆயிடுச்சு. So depression in the T freezing point, same thing, delta TF is equal to, இங்க வந்து T naught F வந்துருச்சு because that is the highest value. Because depression in the freezing point happened, na? Okay, delta TF is equal to molality K, அதோட KF, Ebuloscopic constant of the freezing point depression constant or Ebuloscopic or no, இங்க வந்து the cryoscopic constant, cryoscopic இல்ல student, cryoscopic constant வரும், அங்க தான் Ebuloscopic constant வரும். Okay, or else we can say that the molar depression constant or freezing point depression constant KF, which is, so that is directly proportional to the, see, delta TF is directly proportional to molality. We are giving a removing the proportionality. Okay, we are deleting, I mean we are just removing the proportionality by using this particular KF. So KF is the cryoscopic constant, or we can say that freezing point depression constant also. Clear everyone? Clear? So the difference between the FP of pure solvent T naught F and freezing point of the solution TF. KF is equal to the depression in the freezing point of 1 molar solution. This is the same equation which we have discussed for the Kb also. Kb. This is also very important equation if they, but usually they will give you the water only. So water only you just study it. Okay, unit is K bar K Kelvin per meter or degree Celsius per meter and K dot kg mole inverse. So these are the values. Okay, here this R இருக்குல்ல இந்த R எப்படி calculate பண்றது ஈஸியா நான் சொல்லி கொடுக்கிறேன் next இதுல தான். So this is all the things. See, usually நான் ஏன் இந்த stuff ரொம்ப ஸ்ட்ரெஸ் பண்ணி சொல்லலைன்னா usually they will be giving you the values. Kf, Kb, they will be usually giving. Okay. Now, Kf of the water. If it is water, you have to know it. Okay. Kf of the water is 1 point, children, here. Here point irukku. 1.86 Kelvin kg mole inverse. Clear? Okay. Kb was 0.52. Now, இதுக்கு முன்னாடி நான் ஒரு ஸ்லைட் எடுத்திருந்தேன். ஓகே இங்கேயா சரி ஓகே. So depression in the freezing point is proportional to the lowering of the vapor pressure. I told you, not just the freezing point, depression in the freezing point. This is very important, children, because they will ask you the question like freezing point and depression in the freezing point, which is proportional. So depression in the freezing point is proportional to the delta P. If solute get associated, we have to add I. Okay, and freezing point or boiling below it, only solvent molecules will freeze and not solute molecule. This is also very important. Because the solvent is actually working. The solvent will only undergoing the changes. Solute won't be undergoing any changes. So solvent molecule will be freezing, solute molecules will be staying as that. Now comes the osmosis. Osmosis actually, it's a spontaneous flow of the solvent particle. Now from the solvent particles, it's going from the solvent side to the solute side or solution side. Solvent side la irundha solvent particles vandu solvent side la irundha solution side like pora and oru spontaneous flow, or we can say that low concentration la irundhu solution of low concentration to higher concentration through the semi permeable membrane, through the semi permeable membrane. Solvent la irundhu solution like poradhu osmosis solranga. Neenga osmosis padichirkeenga, correct? Right? Semi permeable membrane சொல்றது natural ஆகவும் இருக்கலாம், artificial ஆகவும் இருக்கலாம். Natural ஆக இருக்கிறது plant cells, animal plant cell, animal membrane என்றால்னா that is an example. Artificial சொல்றது Cu2, FeCN6, silicate of nickel, iron, cobalt. All these are example for the artificial semi permeable membrane. Now, example of osmosis means ஒரு raw mango ஒரு concentrated salt solutionல வெச்சிட்டேனா என்ன ஆயிடும்? They will shrink. Correct? Or else நம்ம வந்து ரொம்ப salt explosion, நம்ம lot of salt experience the water retention in the tissue cell. So what happens? They will be having a lot of puffiness in their eyes, like here they will be having. I used to have that, but it's not because of that. I mean, நான் தூங்க மாட்டேன், தூங்குறது கம்மியாச்சுன்னா எனக்கு இருக்கும். தூங்குறது கம்மியாச்சுன்னா இது மட்டும் இல்லை, I will be like என்னடா நடக்கிறது, என்கிட்ட யாராவது வந்து கேட்டாங்க கூட I don't know what is happening in the universe, I don't know. தூங்குறது கம்மியாக இருந்தால் like I need to get a proper 8 hours to 9 hours of sleep. எனக்கு என் வாழ்க்கையில் பிடிச்சதே தூக்கம் மட்டும்தான். ஸோ அது கம்மி ஆகிட்டேன்னா I will be get irritated and I will be having the same issues also. Even I overslept also எனக்கு இருக்கும். ஆனால் அது பிரச்சனை இல்லை. தூக்கம் கம்மியானதான் கோவம், இரிட்டேஷன், ஆங்க்ரி, மூட் ஸ்விங்ஸ் எல்லாமே வரும். Okay. Now, osmosis pressure, our formula, this one. Okay. So, listen carefully, children. So, in the solvent வந்து solute like போகுது. ஆமாதானே? Listen carefully. The external pressure that must be applied on the solution side to stop the process of osmosis. So, if solvent is going to the solution side, okay, this is what the osmosis. What happens? There is a pressure will be increases. There is a high level pressure that is actually called as the osmosis. So, in order to stop the osmosis, அங்க வெளியில இருந்து யாராவது பிரஸ் பண்ணும். ஸோ என்ன ஆயிடும்? அந்த ப்ரெஷர் நம்ம வெளியே இப்போ இந்த சால்வெண்ட்ல இருந்து சொல்யூஷனுக்கு போகும்போது இங்க அந்த பிஸ்டன் மூவ் ஆயிடும், மேலேக்கு மூவ் ஆயிடும். ஸோ அங்க இருந்து ஒரு ப்ரெஷர் எக்ஸ்ட்ராக்ட் பண்ணும்போது என்ன ஆயிடும்? That pressure will be cancelled. So when the P external are equal to pi, which is both has to be equal. Okay. Now the equations. Okay. So pi is equal to ICRT. C is the concentration, R is the universal gas constant, and T is the temperature. So C we know that number of moles by volume, concentration 1. Okay, which comes to the molarity I'm taking, number of moles divided by the volume. So I'm just giving that N by V RT, and here what I done is I have just taken this particular value here. So pi V is equal to, that is osmosis concentration into V is equal to INRT. INRT means I is the Van Hoff factor. You have to just நீங்க படிக்கும் போதே அது போட்டு ப்ராப்ளம் பண்ணிக்கோங்க, இல்லைன்னா கடைசியில் நீங்கள் மறந்துடுவீங்க. ஒரு ப்ராப்ளம் வரும்போதே அந்த இக்குவேஷன்லேயே ஐ போட்டுக்கோங்க, இல்லைனா மறந்துடும். ஃபார் ஷுவர் யூ வில் forget it. ஓகே, ஸோ பை வி இஸ் ஈக்குவல் டு என் சொல்கிறது நம்பர் ஆஃப் மோல்ஸ் இஸ் ஈக்குவல் டு மாஸ் ஆஃப் தட் பர்டிகுலர் சப்ஸ்டன்ஸ் டிவைடட் பை தி மோலார் மாஸ் ஆஃப் தட் பர்டிகுலர் சப்ஸ்டன்ஸ் which is equal to W by M RT. So where is R is a universal gas constant. Now universal gas constant ma'am அது ரொம்ப டிஃபிகல்ட்டாக இருக்குன்னு இருக்கிறவங்களுக்கு ஒரு ஈஸி வே தான், லிசன் பண்ணிக்கோங்க. This is the way I will stand here. Okay, ஸோ ஆர் வேல்யூ சொல்கிறது ரெண்டு இது இருக்குது, ஐ மீன் ரெண்டு வேல்யூஸ் இருக்குது. ஃபர்ஸ்ட் ஒன் ஹியர், ஓகே ஹியர் 8.314 ஜூல் பர் மோல் கெல்வின், ஜூல் பர் மோல் கெல்வின் சொல்கிறது. இட்ஸ் அப்ராக்சிமேட்லி நமக்கு என்னதான் எழுதலாம், we can write it as a 2.53, 25/3, not 2.53, 25/3. When we can use that value for the R is when the volume is given in the meter cube, when the temperature is given in the Kelvin, when the pi is given in the, or the particular osmosis pressure they are asking you into the Newton bar meter square. If these are the units, usually this one given, this is actually same for everyone, both R values. This will be different and this will be different. In NEET exam option அவங்க கொடுத்திருப்பாங்கல்ல 8 ATM, 8 Newton per meter square, அந்த மாதிரி கொடுக்கும்போது you have to know it. அந்த Newton per meter square தான் இருக்கிறேன்னா you have to go for 25/3. If it is Newton per meter square, the volume will be in the meter, I mean Newton per meter cube, the volume will be in the meter cube. Usually இதுதான் கொடுப்பாங்க, இன்னொரு நிஜம், பட் ஸ்டில் note it down. So you 8.314 நீங்கள் 25/3 எழுதிக்கலாம். It's for the faster calculations. Okay, next one is R value 0.0821 literal ATM bar mole dot Kelvin la R value நம்ம 1/12 we can take it. 0.0821 na we can take it as 1/12. When the volume is in the liter, temperature is both here and here, it's Kelvin only. Okay, volume is in the liter, temperature in the Kelvin, pi is in the osmotic pressure ATM. Usually this one will be asking. Usually அவங்க ஏடிஎம்ல தான் கொடுப்பாங்க. There are many cases where they can given in the Newton bar meter square also, but usually they will be giving like this. Okay, clear everyone? Okay, so Van Hoff factor, okay, this இது நான் வந்து I will tell you. Van Hoff factor I pi is equal to NV by RT CRT, ideal gas constant. Okay, R or S is also equal. Okay, ஆரும் கொடுக்குறாங்க, சில டைம் எஸ்ஸும் கொடுக்குறாங்க. ஓகே, ஸோ திஸ் இஸ் if two solution concentration and C1 and C2 are kept separately by SPM, that C1 is greater than C2. ஓகே, சொல்யூஷன் 1 சொல்யூஷன் 2ல C1க்கு நிறைய கான்சன்ட்ரேஷன் இருக்குது, C2 என்னை காட்டிலும். அப்படின்னா then the solvent particles movement take place at lower concentration with higher concentration. And if we are adding extra pressure, what happens, that particular அந்த ஒரு osmosis stop பண்றதுக்கு we have to give the external pressure. Are you getting my point, children? Are you getting my point? So P external will be is equal to இதோட pi1 minus pi2 will be the P external. Okay, here we have to give the ICRT. Okay, osmotic pressure of very dilute solution are always quite significant, so it is measured by in the lab very easy. Now reverse osmosis. This is distillation, children. Reverse osmosis. Listen carefully. The pressure applied on the solution is more. So I told you, அவங்க வந்து ஒரு see. See, சால்வெண்ட்ல இருந்து சொல்யூட்லேக்கு போகுது, அதனால ஒரு ப்ரெஷர் வருது, அது ஆஸ்மோசிஸ் ப்ரெஷர். அந்த ஆஸ்மோசிஸ் ப்ரெஷர் கேன்சல் ஆகிறதுக்காக பி எக்ஸ்டர்னல் கொடுத்தா போது ஆஸ்மோசிஸ் ப்ரெஷர் கேன்சல் ஆயிடுச்சு. இனி பி எக்ஸ்டர்னல் இஸ் கிரேட்டர் தேன் த ஆஸ்மோசிஸ் ப்ரெஷர், வி ஆர் கிவிங் மோர் எக்ஸ்டர்னல் ப்ரெஷர் விச் இஸ் கிரேட்டர் தேன் த ஆஸ்மோட்டிக் ப்ரெஷர் மீன்ஸ் என்ன ஆயிடுவாங்க, வாட் வில் பி ஹேப்பனிங், reverse osmosis நடக்கும் அந்த வழி அவங்க திரும்பி போவாங்க. So the pressure applied on the solution side is more than that osmotic pressure. Then the solvent particles will move from the solution to the solvent side. Are you getting my point, children? P external is greater than. Clear? It is used in this particular RO filters and all there. Now, based RO filters and this distillation of the seawater, we will be using that particular process. Based on the difference of the osmotic pressure, we can classify the solution into isotonic, hypotonic and hypertonic. This is important. Isotonic means we can say that they will be both having same concentration. When both having same concentration means always remember their osmotic pressure will be equal. Clear? Because pi is equal to CRT now. At constant temperature. See, pi is equal to CRT. When it is at the constant temperature and C, pi is equal to C1. Pi is equal to C1 again for the two components. I mean, write it as a C2. That will be much better. C2. So, when C1 is equal to ayyo. Just a second, children. Okay, when C1 is equal to C2 means pi is equal to pi 1 is equal to pi 2. Are you getting my point, children? That's why pi 1, that's simply you can make a note of it like pi 1 is equal to pi 2. Okay, I hope this is clear. Okay, next one. So, hypertonic and hypertonic. Hypertonic, listen carefully. If two solution 1 and 2, if two solution 1 and 2 are such in way that second one is more osmotic pressure than the one, then the second one is hyper. When they have more osmotic pressure, they are hyperactive. So, hypertonic. And the first one is hypotonic. So, if this is more osmotic pressure means this is hyper. This is less osmotic pressure means this is hypo. Here it is like they are given it like pi 2 is greater than pi 1. Na? So, this will be hypertonic. This will be hypertonic and this will be hypotonic. Clear? The pressure is applied on the hypertonic to stop the flow of the solvent particles. So, inga vandu nama pressure apply pannom because they are so hypertonic na, in order to stop this particular movement flow. Okay, so hypotonic, isotonic, hypertonic. Hypotonic means they will hypo means there will be more. Isotonic means there is no net loss or gain. Hypertonic means net water loses the shrink. Because see, hypertonic means வெளியிலிருந்து உள்ள இருந்து வெளியே போயிடுவாங்க. Hypo means உள்ள ஒன்னும் இல்ல. So they will be coming from the outer surface to inner surface. இதுக்குள்ள வந்துரும். இங்க உள்ள நிறைய இருந்ததனால வெளியே போயிடுவாங்க. They will shrink. Now, osmotic pressure applications, determination of the molecular mass of the solute. From that equation itself, we can consider molecular mass of the solute is equal to W, that is the mass of the solute given mass, RT divided by pi V. Okay. And the widely used in determining the molecular mass of the proteins and other biomolecules which is thus not stable at the higher temperature. This method is having an advantage over other method because they are as the pressure measure is around the room temperature. W is the mass of the solute, V is the volume of the solution, pi is the osmotic pressure, T is the temperature, R is the universal gas constant. If the solute gets associated or dissociated, the theoretical molar mass of the solute will be different from the experimental one. So, if there is a, see that's what I na, Van-Hoff factor, if there is a dissociation and association happens means there will be having theoretically and calculatedly or experimentally, there will be difference. That's what the theoretical molar mass of the substance I will be divided by the experimental molar mass of the substance. Now, dialysis also, this is not required, children. Clear? Now I want you to write something. Just a second. So, this is all our chapter. Now, there is another point here. Where did I write it? Just a second, children. Give me a second. I was writing it somewhere. I don't remember. Just give me a second. Yeah, it's here. I want you to write. This is actually a kind of a very important points to remember. So, listen carefully. Important points to, I will try to give it in all the chapter, okay? எல்லா சாப்டர்லயும் நான் தரதுக்கு ட்ரை பண்றேன். First of all, pi is equal to CRT, or we can say that NV by NVRT. Okay, this is the pi is equal to N by V RT. Okay, this is the first one. Okay, next one is delta P by Pns is equal to chi of solute. Chi of solute is the relative lowering of the vapor pressure. This is very important one. And the next one is delta TB is equal to I into KB molality. Freezing point is equal to I into KF molality. This is molality, children. And nothing else. There is another point also you have to add here, children. I'm just drawing in another line here. I don't know when I will be drawing it correctly. When the number of solute particle increases. Okay, what happens when the number of solute particle increases? Always remember, what is this? Osmotic pressure increases, relative lowering of the vapor pressure increases because solute particles, no? Delta P, lowering of the vapor pressure increases, vapor pressure decreases, delta TB increases, just boiling point increases, delta TF increases, and freezing point decreases. This is very important one, children. I will just இது ரொம்ப easy method of following the chapter. கடைசி லாஸ்ட் பாயிண்ட் இருக்குல்ல, கடைசி நிமிஷத்துல எப்போவுமே இது வந்து இதை வச்சு கொஷின் வைப்பாங்க அவங்க. ஓகே, நெக்ஸ்ட் ஒன் இஸ் நெக்ஸ்ட் வந்து இன்வெர்ஸ்லி ப்ரொபோர்ஷனல், டிரெக்ட்லி ப்ரொபோர்ஷனல், அது கூட டிஸ்கஸ் பண்ணுறேன். ஓகே, ஜஸ்ட் 2 more minutes, children. ஃபார் எக்ஸாம்பிள், you have the freezing point, right? Freezing point is always inversely proportional to I. I ஓட proportionality தான் நம்ம சொல்ல போகிறோம், Van House factors ஓட. freezing point increase ஆகும்போது யூஷுவலி I வந்து டிக்ரீஸ் ஆகிடும். I வந்து டிக்ரீஸ் ஆகிற ப்ராடக்ட்ஸுக்கு தான் freezing point increase ஆகிடும். சேம் திங். ஸோ வாட் வில் பி ஹேப்பனிங் டு த, நவ் டெல் மீ வாட் வில் பி ஹேப்பனிங் டு த BP? BP will be increasing with the increase in the I. Because FP and BP are inversely proportional, na? So BP will be increasing with increase in the I, and I is inversely, directly proportional. Directly proportional to difference in the temperature, freezing point. Now, delta TF is inversely proportional to freezing point. This you know already, right? Correct? Now, vapor pressure. In terms of vapor pressure also it will be inversely proportional to I, because FB and vapor pressure is directly proportional, so it will be inversely proportional to I. Clear everyone? இது வந்து நீங்க நோட் பண்ணி வெச்சுக்கோங்க. This is much better. Okay? Now another one more point here I will write here. இங்க எழுதுறேன். Boiling point to vapor pressure inversely proportional. Am I correct? Vapor pressure freezing point directly proportional. Correct? Okay, இதெல்லாமே எழுதி வெச்சுக்கோங்க. These are very important. And I can give you a formula also for I. I is equal to M into N. Okay, இந்த ஒரு ஃபார்முலாவை நோட் பண்ணி வெச்சுக்கோங்க. We will do the problems that time you will know what is N. N சொல்றது அந்த இப்போ Na2SO4 is kind of 2Na plus SO4 2 minus, so 3 will be N. That is the A. This is molality. இந்த ஃபார்முலாஸ் எல்லாமே நோட் பண்ணி வெச்சுக்கோங்க. These are very important. கொஞ்சம் அதிகமாக இம்பார்ட்டண்ட்டாக இருக்கிற ஃபார்முலாஸ் தான். கிளியர் எவ்ரி ஒன்? So any doubts in this? I hope this chapter is clear. I just take little more time. ஒரு 2 ஹார்ஸில் நான் முடிக்கணும்னு நினச்சேன். 2 hours 45 minutes ஆயிடுச்சு. So that's okay. These are the important points which you have to remember in this particular chapter related to the colligative properties. Okay, இதிலிருந்து நிறைய கொஷின்ஸ் கேட்பாங்க. இதிலிருந்து இந்த வச்சு நிறைய கொஷின்ஸ் இருக்கும். I will tell you. நம்ம கொஷின்ஸ் பண்ணும்போது உங்களுக்கு தெரியும். ஓகே, நிறைய கொஷின்ஸ் கேட்பாங்க. ஸோ ரிமெம்பர் ஆல் திஸ் ஃபார்முலாஸ். திஸ் வில் பி மேக்கிங் டு ஹெல்ப் த நீட் ப்ரிப்பரேஷன்ஸ். ஓகே, ஸோ ஐ ஹோப் திஸ் செஷன் இஸ் ஹெல்ப்ஃபுல் ஃபார் யூ. I covered all the particles, all the topics which is very very important. I have covered all the topics, not important one also. Basically இருந்து ஸ்டார்ட் பண்ணியிருக்காங்க. ஸோ ஒரு மேக்ஸிமம் 2 hours 45 minutes is not a big deal for you guys, right? ஸோ இது பார்த்துக்கோங்க. நம்ம இதோட ப்ராப்ளம்ஸ் வந்து we will do in the live sessions. Okay, I hope this is clear for you and tata bye bye for now. இனி உங்களுக்கு வந்து எந்த சாப்டர் வேணும், இனிமேல் ப்ராபப்ளி நான் 11th சாப்டர் தான் இருக்கும். ஸோ எந்த சாப்டர் வேணும்னா அந்த சாப்டர் கமெண்ட் பண்ணுங்கள். ஸோ ஐ வில் பி லைக் ப்ரையாரிட்டி பேஸ்டாக அந்த சாப்டர் நான் எடுக்கிறேன். Okay, so I hope this session is helpful. If you like the video, if you find this session is helpful, please do like the video. And for more related like this type of content, like academic related content, please do like the channel also, like subscribe the channel also. Okay, so bye bye, have a good day, study well, prepare well. Okay, you are going to rock.